Hello and welcome. In this video, let's understand how we can install SQL Server and SQL Server Management Studio on a Windows machine. Okay, so let's start with SQL Server installation. For that, you need to search download SQL Server and you need to pick the first link. Once you are at this link, you will notice there are multiple options to download. There is SQL Server for on-premises, for Azure, for developers, and there is one Express edition also. For learning purpose and for development, we need to install SQL Server Developer Edition. So let's click on download now and it will download one file. So let's go to downloads folder. I have this file here, right? I will run this file and it will ask you which type of installation you want to do. There are three options. One is basic, custom, and download media. For this video, let's go with the basic installation. And after this, it will give you terms and conditions. You can read it and at the end, you can click on accept button. Right here, it will give you at which location it is going to install the SQL Server. You can click on install here and it will start the installation. It will take a few minutes to complete the installation. So let's wait for it to complete. Once installation is completed, you will get this type of window. Here you will see some details like this is the connection string. Here you can see what is the server type and the database name. So you can use this connection string to connect your database. Also, you will see where the installation was done. Here is the logs folder, here is the media folder, and here is the resources folder. Right, so installation has been completed successfully. Now let's close this window and click on yes. And now what you can do, you can open the command line and verify if the installation has been completed successfully or not. So let's search for SQL CMD. So this is the SQL command line. Once you open this, you can start writing your queries here. Let's see the current date and time. So for that, I can say select get date. I'll say go and I will get the current system date and time. Right, so this is how you can execute commands from command line, but we don't want to do this. We want to execute our queries using SQL Server Management Studio. So let's see how we can install SQL Server Management Studio. Okay, now, so go to Google again and here search for SSMS and click on the first link that says install SQL Server Management Studio. And here you will find this link that says download SSMS 21. And guys, now SSMS is part of our Visual Studio installer. So you can open this file and it will open the Visual Studio installer, right? So let's give continue here. So it will ask you what components you want to install along with SSMS. So for now, I will not select anything and I will just click on install. Here you can see it will take 2.13 GB of space. And this is the location where it will install the SSMS. So I will click on install and it will start installing the SQL Server Management Studio. Let's wait for this to complete. So our installation is completed. So now let's click on launch to open SQL Server Management Studio. It will ask you to sign in to your Microsoft account or your GitHub account. For now, let's skip this and just open SSMS. So here I'm getting some pop-up that says if I want to enroll for some new feature, I will just say no here. And here I can try to connect with my local server name, like this is my machine name and I'm using Windows authentication. Let's click on connect. And you see I am connected to my database. I can right click here and click on new query and I can say select get date and I can click on execute and I'm getting the current system time That's it for this video, guys. In this video, we have understood how we can install SQL Server and SQL Server Management Studio and start using it and start executing our queries. Hello and welcome. In this video, let's understand how we can create a database in Microsoft SQL Server. So here I have opened my SQL Server Management Studio. Once you are connected to your database, you can see we have this database folder here. And currently there is no database created. To create a new database, there are multiple ways. One, you can click here and click on new database. This will open up a wizard. Here you can provide the details and create the database. But in this demo, we will be creating database using SQL query. So let's click on new query, and here to create a new database, we need to run create database statement. So let's type create database. And then we need to give a name to our database. This can be anything, but it should be a unique name. We cannot have two databases with the same name. Okay, so let me give a database name here. Let me give demo here. And then we can either select this and click on execute, or we can just click on execute directly also. Right? Commands completed successfully. Now if you go to your databases and right click here and click on refresh, you can notice we have created this demo database, right? So this is our newly created database. If you open this database, it will have all these folder tables, stored procedures, functions. So this is how you can create a database. One more thing I want to explain here. Once the database is created, it will create two important files in your file system. If you right click on the demo database and go to properties and select files here, you can see it has created two files here. One is the rows data that will actually hold the actual data that you are going to store in your tables. And the second one is the logs. Whenever you will perform any transaction like update, delete, those kind of operations will be logged here. And if you want to know the path where this file will be, you can see here in the path at this location we will have these two files, demo.mdf and demo_log.ldf, that will have the log data. You can visit this path also. Let me copy this path from here and let's open File Explorer and let me paste this path. You can see we have this demo.mdf and demo_ldf. So whatever data you will create in your database will get stored in this file demo.mdf, and demo_log will be used to write logs inside it. So that's it for this video. In next video we will see how we can create tables and perform insert, update and delete on a table. Hello and welcome. In last video we have seen how we can create a database in SQL Server. Now let's see how we can create some tables inside our SQL Server and start inserting, updating and deleting data in it. One more thing, currently if you see here, we are inside our master database, but in the last video we have created this demo database. So to switch to this database, either you can open this drop down and select demo database, else you can say use demo. Right? If you execute this particular statement, now we will be switched to demo database. You can see in the drop down also, now we are inside demo database. Okay, and you can confirm that in the rightmost corner also, on the right hand side bottom, you can see we are connected to demo database. Okay, now let's see how we can create a table in our demo database. To create a table, we need to say create table, and then we need to specify a name. Okay, so let me specify a name here, customers. Okay, so this will be the name of my table. And when we are creating a table, we need to specify the columns. So let's specify the column. Let me say customer name. Now we need to specify the data type. The customer name will be of string data type, and the equivalent of string in SQL Server is varchar, or you can use nvarchar. We will understand what are the different data types available in SQL Server in the later videos. But for now, let's create this column with of type varchar 100. Okay, now the customer will have age also, so let's create an age column. and this will be a number, so we can say integer, right? So int is also one of the data type. Okay, till now we have created these two columns. Now let's see how we can add a date time column. Let's say I want to add date of birth also, so let me say DOB, and I can specify date time here. So this data type can be used to store a date time. Okay, now we have covered string, numbers, and date data types. Now let's say you want to store if the customer is a premium customer or not. Basically, we want to store true or false. And in SQL Server, we don't have anything like Boolean data type. So instead of that, we have a bit data type. So what we can do, we can create a column, let's say is premium, and we can say bit here. So bit is also one of the data type. In this, we can store 0 and 1. That will be basically our true or false. So there are other data types also in SQL Server, but for now, let's create our table with these 4 different data types. Let me select everything and click on execute. Now our table has been created. If you open your demo database here and refresh it here, you can open the tables folder and you can see your customer table has been created. If you expand this customer table and expand the columns folder, you can see these are the columns that we have created: customer name, age, DOB, and is premium. Okay, so this is how you can create a table in SQL Server. And now let's see how we can see data which is present in our SQL Server table. To see the data, we have select query. So we can execute select query on this table. So let me write select star from customers. It will select, star means everything. Basically, it will select all the columns of this table. From where it will select? It will select from customers table. So this is the syntax we use to get the data from a table. Select star from customers. Okay. So let me execute this. And you see, we did not receive any rows. You can see here, 0 rows has been returned because currently we don't have any data. Okay. And to insert data in a table, we can use insert statement. Insert. After insert, we need to specify in which table we want to insert. So we need to say insert into customers. Okay. We need to specify the columns. For which columns we want to add the data. So I want to add the data for customer name. I want to specify age. I want to specify date of birth. And I also want to specify if the customer is a premium customer or not. Okay. So I am saying insert into table, and then I have specified the columns within this parenthesis, and all the columns are comma separated. Okay. Once this is done, what we can do after this, we need to specify values. Okay. So what values these columns will hold, right? So let me say I want to provide customer name as Martin. Let me say age as 35, date of birth 2010, third month, and let's say date was 15. Okay. And for the is premium, let me say this customer is a premium customer, so I will say 1 here. Now you see what I'm doing here. For customer name, I have specified Martin. And if you notice, I have specified this Martin in single quotes. So this is the syntax we use when we are providing a string value. But if you see how I am providing the age, for age, I can directly provide 35. No need to use single quotes when you are providing numbers or let's say decimal numbers. Now let's see the DOB. I mean, this is of date time format, and you can see I am providing the date time here in this format. We will cover the different formats that we can use to provide date in our later videos. Okay, but for now, let's move forward and see how I'm adding data for is premium column, that is of bit data type. I'm directly providing 1 here. Here also, we don't have to use single quotes. Let me select this and click on execute, you can notice the message here, one row affected, meaning one row has been added to our table. Now if I execute the same query, select star from customers and click on execute, you can see I am getting the data here, Martin 35, this, and everything that we have inserted here is getting reflected in our select query. Now let's see how we can update the data in our database. Okay, so let's say I want to update the age from 35 to 25. So what we can do, we can say, then we need to specify the table name, which table we want to update. Let me say I want to update customers table, and what I want to update, I want to set age to 25. So let me say set age equal to 25. And when we are executing update statements or delete statements, it is always recommended to provide where statement. We will understand what is a where clause and how to use that. But for now, let's remember, if you don't provide a where clause here, it will update all the rows in our table. Currently, we have just one row, so it will not affect much. But if you have like 1,000 rows and you update your table with this statement, not providing where clause, it will update all the 1,000 rows. So it's always recommended to provide where clause when you're updating or deleting data from the table. So let me provide where customer name equal to Martin, right? Because I want to update age only for Martin customer, right? So this is how you can update data in your table. Let me execute this. You can see again one row affected, and again if I see my data again using the select query, I'm getting the age as 25 now. Okay, right. So update is also working. Now let's see how we can delete data from our table. Currently we have only one row, so let's say I want to delete this row. So to deleting the data, we have to use delete statement. Okay, now we need to say delete from where. I want to delete from customers table. Okay, and what I want to delete, if you execute this statement like this, it will delete all the rows from your table. As I mentioned earlier, when you are updating or deleting data in your table, you need to specify where clause. It is not mandatory, but it is always recommended, because if you don't provide where clause, it will update all the rows or it will delete all the rows from your table. So let's specify the where clause here. So let me say where. This time let's use age in our where clause. We can say 25, right? And we can delete the customers who are having age equal to 25, and currently there is only one row, so it will impact only one row. So one row affected. Now again if you check your table, now you can see now there is no row present in our table because we have deleted the one row that was available, right? Now our table is totally empty. Now let's see how we can delete a table itself. Currently we have the table, right? If you see tables folder here, right click and refresh here, we still have this customer table, but this is currently empty. Okay, so if you want to delete a table, you can execute drop statement. So let me say drop, and let me specify what I want to drop. I want to drop a table, and what is the name of the table? The name of the table is customers. Okay, and guys, when you are executing drop, you cannot provide a where clause or anything. When you are executing drop statement, it will delete the table, and it will also delete the data that is present inside that table. So be very cautious when you are executing drop statement. Okay, so let me execute drop here. Command completed successfully. Now if I right click on my tables, you can see table has been gone. I don't have the customer table in my database now. And if I try to select data in my customer table now, we will get the error. You can see invalid object name customers, because now we are not able to find the customer tables. Okay guys, that's it for this video. In this video, we have seen how we can create a table using create table statement, how we can select data from table using select star from table name syntax. Then we have seen how we can insert data. Then we have seen how we can update the data. And then we have seen how we can delete data from a table. And finally, we have seen how we can drop a table from our database. In this video, let's see how we can rename a column of a table. If you see here, I have this employee table and you can see currently it has 20 rows and these are the 5 columns that I have. And let's see the script that I have used to create this table. You can see this was the script I have used and I have given the name employee name as my second column. Now let's say I want to rename this to EMP name. Instead of complete employee name, I want to change it to EMP name. To rename a column, basically you need to use one stored procedure that is an inbuilt stored procedure, and the name of that stored procedure is sp underscore rename. Okay, so we need to execute this using the execute keyword. Okay, and then we need to specify what we want to rename. Basically, we want to rename the column employee name from table employee. So let's copy this table name. We need to specify the table name dot the old column name. Currently we have the column name as employee name, right? So let's specify this, and now let's specify what should be the new column name. New column name should be EMP name. Let's give that here. Now we need to specify what exactly we are renaming. Here we are renaming a column, so let's specify column here. So these are the 3 parameters I need to give to this SP, that is the SP underscore rename. Now let's select this statement and click on execute. Getting a message here like changing the object name could break the scripts, right? But that's fine. Currently we don't have any stored procedure created for this table. And now if you do select star from employee, you can notice now my column has been changed to EMP name. This is how you can rename a column of a table in SQL Server. We have this table employee data, and if you open employee data here, you can see these are the columns here. We have this EMP name with varchar 255. Let's say I want to increase the size of this column from 255 to let's say 500. To do this, we need to use alter table query. So let's write alter table. Then we need to specify the table name, that is employee data. And then we need to say alter. We are changing the size of a column, so we need to say alter column. And which column I want to modify? I want to modify employee name. So let's put it here. And now let's specify the size. I want to specify the size here. So this is a varchar from 255. Now it should be 500. Let's execute this. Command has been completed. Now if you refresh this table and open the columns here, you can see now the size has been changed to 500. So this is how you can change the size of a column in SQL Server. Now let's see how we can change data type of a column. For that, let's take example of salary column. Currently it is of integer type. Let's see how we can change this salary from integer to a big integer. To do that, again we need to use alter table, and we need to say the table name, and here I want to alter the column. Which column I want to alter? I want to alter the salary column, right? So let's put it here, and from integer I want to change it to big integer, right? Let's execute this and refresh the columns again. You can see now the salary column has been updated to big integer data type, right? So this is how you can change data type of a column. And guys, make sure this will be applicable only for the applicable columns. Let's say this table is having employee name here, right? And you want to be able to change the employee name to the integer data type because the data types are not compatible. If you try to do that, you will get the warning. Let's say I want to change employee name here Let's say I want to change it to integer. Let's see what will happen when I execute this. When you execute this, you will get this error because the SQL Server won't be able to convert this name to type integer and will get this conversion failed error. That's it for this video. In this video, we have understood how we can change the length of a column or how we can modify the data type of a column in SQL Server. In this video, let's understand how we can rename a table in SQL Server. Currently, I have this table employee and currently we have 20 rows in my table, right? Let's say I want to rename employee table to employee data table. Okay. Again, we can use sp underscore rename stored procedure. So let's execute that one, sp underscore rename, and let's pass the table name. The old table name is employee, and I want to specify the new table name also. So I want to give the new table name as employee data, right? If I execute this statement, we are getting a warning, but if you select star from employee now, you will get an error because now there is no table with employee name. And if I do select star from employee data, you can notice I'm getting all my 20 rows back, right? So this is how you can rename a table in SQL Server. In this video, let's understand how we can add a new column in a table. Currently, I have this employee data table and we have 5 columns in this. We have ID, employee name, email, salary, and is permanent. Let's say I want to add one more column, that is date of joining. To add this column to our table, we need to use alter table command. So I need to say alter table and I need to specify the table name here, and then I need to give the column which I want to add. So that I need to specify using the add keyword. So I need to add date of joining, right? So this column I want to add and the type of this column should be date time, right? Let's execute this. You can see command has been completed. Now if you select star from employee data, you can notice we have this date of joining here. But currently if you see date of joining is null here, let's see how we can give a default value to our date of joining. Let's do one thing. Let's drop this column and add it back with some default value. To drop a column, we need to again use alter table command. And again, I need to specify employee data as my table name. And then I need to say drop column and the column name that I want to drop. Okay, let's execute this. Now, if you do select again on this table, you can notice we again have the 5 column date of joining has been dropped. Now let's add this column back, but this time I also want to specify some default value. Let's say I want to give the default values as today's date. So the today's date will be the date of joining. While adding this column, you can say constraint and let's give a constraint name. I need to give a default value. So let's say default date of joining, right? And this is a default constraint. So let's say default here and the default value that I want to give. So let's say default value will be today's date. So today's date is 2025 November 15, right? And let's say with values and execute this. Command has been executed. Now let's do select star from employee data. You can see now this time we have added a new column, but this time we also have some default value against our new column. In this video, let's understand how we can rename a database in SQL Server. Currently, I have this demo database. You can see here in our databases, we have this demo database. Now let's see how we can rename this database. Before renaming a database, you need to make sure your database is in single user mode, which means your database is not connected by someone else. If someone else is also working on the database, you want to be able to rename it. So first you need to make your database in a single user mode. To do that, you need to fire alter database query. So let's say alter database, and we need to specify the database name. So the demo database is the database which I want to rename, and I want to set it to single user, right? With rollback immediate. If you execute this query, this will make our database to a single user mode. Let's execute this. Okay, this is completed. Now you can go ahead and rename your database. To rename the database, again, you need to use alter database query. So let's say alter database. Which database I want to rename? That is demo. And I want to modify, right, the name of the database. So let's say modify name and then specify the new name that I want to give here. Let's say I want to give demo new. So what I'm saying alter database and then the old database name, then modify. What I want to modify? I want to modify the name of the database. Let's execute this. The database name has been changed to demo new, and you can see at the rightmost corner we have this demo new here, and in the top also now demo new has been selected. And if you refresh here, the database has been changed to demo new, but you can see here what it says, it is in single user mode because we have changed this database to single user. Now let's change it back to multi-user so that other people can also connect to our database. We can again use this alter database query, and I want to make demo new database, and let's set it to multi-user, right? Let's execute this. This is done. Now if you refresh this here, you can see single user warning has been gone, and now our database is back to normal. So guys, this is how you can rename your database in these 3 simple steps. In this video, let's understand about primary key in SQL Server. Primary key is a constraint that uniquely identifies each row in a table. It enforces data integrity in tables. Let's first understand why primary key is needed and what is the importance of having a primary key in a table. Okay, so I have connected to my database, and let's switch to demo new database. Here currently I don't have any table. You can see here in tables folder there is nothing. Let's first create a table that is not having a primary key. I am creating a table with name employees, and I am adding 3 columns: employee name, salary, and department name. Let's create this table, and now I am inserting 3 rows in my table. So let's insert this also. Now let's check the data present in our table. If I do a select star from employees, I am getting these 3 rows. Currently, if you notice, I have names which are unique: Mark, Peter, and Sarah. Let's say I want to find the salary of Peter. What I can do select star from employees where employee name equal to, I can say, Peter, right? If I execute this, I will get salary, so I can specify salary instead of specifying select star. And if I execute this, I will get 60,000, right? So this is fine. But let's say one more employee joins our company and he is also having the same name as Peter. So let's say Peter, there is one more Peter. Let's say he's earning 50,000 and he's working in HR department, right? So now we have 2 Peters. One is working in sales department, one is working in HR department. Now let's insert this also, right? And now let's again check our data. You can see here we have Peter in sales department, Peter in HR department. If I ask you to find the salary of Peter and you run this query where employee name equal to Peter, you will basically get 2 records, right? So if I run this query, I will get 2 records, 60,000 and 50,000. Now how we will find what is the salary of the Peter we are looking for, right? We need to specify the department. So we can specify where department equal to HR, then we'll get the salary of the employee Peter who is working in the HR department. But let's say in future one more Peter will come and who will also join the HR department. Then how we will find the salary of that Peter? This is why table should have a primary key. Primary key can uniquely identify a record in a table. So let's do one thing. Let's create the same table with a primary key. Okay. So let's drop this table, drop table employees, execute. Table has been dropped. Let's create the employees table with a primary key. Creating a primary key is very simple. When you are creating a table, you can specify the column which should be used for your primary key. Generally, we will make our primary key for a column that will have unique values. For employees table, we will have employee ID that will have unique values. So let's say employee ID that will be of integer type, right? And to make this employee ID as primary key, we need to specify primary key keyword here. So we can say primary key, and that's it. If I execute this time it will make our table with a primary key. Let's execute this. Okay, commands has been executed. Now let's refresh the table and we have this employees table. And if I expand this and go to columns, you can see employee ID and you can see one little key icon here which specifies this column is a primary key. You can see here PK, which stands for primary key, and you can go to keys column and you can say this is the primary key which has been created on this table, on the employees table. Now let's see some of the features of primary key. Table can have only one primary key. If you try to have two primary keys, you will get the error. And a primary key can be defined on one column or the combination of multiple columns. Right here we have defined primary key on a single column, but we can combine multiple columns and create a composite primary key that we will understand in the next video. A primary key cannot exceed 16 columns. So when you are creating a composite primary key, you cannot involve more than 16 columns. And primary key do not allow null values. This is very important. And primary key column will not allow duplicate values also. Right. So let's try to insert some data here. Let's say I will insert employees, but this time I will also specify the primary keys. So let's say Mark is having employee ID as 101 and so on. So I have specified the employee IDs here, right? Let's execute this. Data has been inserted, but let's try to insert null in our table, right? Let's try to insert null for our primary key. Let's see what will happen. Let's say instead of 104, I will say null here. Let's try to execute this. You can see here we cannot insert null into column employee ID because employee ID is our primary key. And if you try to add a duplicate value, let's say you want to add employee ID 101 again, you will again get the error because this is again a violation of primary key constraint, right? We cannot insert duplicate values in this column. So primary key column will not allow duplicate or null values. All columns defined within the primary key constraint must be defined as a not null column. Okay, so if you are creating a composite key, then all the columns which you are considering for a composite key should be not nullable. So this is how you can create primary key in SQL Server. But let's say your table is already there and you want to add primary key once the table is created. Let's see how that can be done. Let's drop this table first. Table has been dropped, right? Now let's say I will recreate this table without having the primary key. Let's execute this and let's insert this data also, right? So we have again 4 columns here, and if I refresh my table here, you can notice in columns I don't have that key icon because the primary key has been removed now. Now let's see how we can add it in an existing table. So I want to make employee ID as my primary key. To do that, we need to say alter table. I want to alter employees table and I want to add primary key here, and in the parenthesis I need to specify the column. I want to make employee ID as my primary key. So if I execute this, we are getting the error here, because if you read this error, primary key constraint on nullable column in this table. So as we understood earlier, when you are creating a primary key, that column should be a not nullable column, right? So we need to define this column as a not nullable. So let's drop the table again. Table has been dropped. Now, when creating this table, we need to specify employee ID as the not null. It means we cannot insert null for this column. Let's create this table again. Now let's add the data. Now again, if you refresh your employees table, still we don't have the primary key on this table, right? To add the primary key on a existing table, we need to run this particular statement. Alter table, table name, add primary key, and within the bracket, we need to specify the column on which we want to create primary key. Let's execute this. This time primary key has been added. Now let's refresh this table here, open columns. You can see now we have this key icon on employee ID, and if you go to keys folder, you can see we have this primary key created for us. And I want to specify one more syntax that you can use when adding a primary key while creating a table. Let's drop the table again. Okay, so previously we have seen how we can add the primary key when creating the table. So we can specify primary key here that will create the primary key for us. But there is one more way. Instead of specifying it here, what we can do, we can specify it at the end. What we can do, we can say constraint. Now we can specify the primary key name. If you notice here the primary key name was generated automatically by SQL Server, but here we can define our custom name also. So let's specify a custom name here. I can say pk underscore, I will say employees, and I'm specifying this primary key on employee ID. So let's specify that column, and then we need to specify what type of constraint I'm giving. This is a primary key constraint, and then I need to specify the column which should be used for the primary key. Then I can specify the employee ID here. So this is one more syntax that you can use to create primary key on a table. Let's create this. Let's refresh the employee table again. This time again we have this key symbol on employee ID, and if I go to keys folder, you can see this time the primary key has been created with the custom name which we have specified here. So that's all for this video. In this video we have understood the basic concepts about primary key. In the next video we will understand what is a composite primary key. In this video, let's understand what is a composite primary key. In the last video, we have seen what is a primary key, and we have created employee ID as our primary key. When we are creating this primary key, we have defined this employee ID as our primary key column. In composite primary key, we can define more than one column. Let's see how that can be done. First, let's drop this table again. This time, I will be creating a composite primary key. So let's say I want to keep the combination of employee ID and employee name as unique. Employee ID can be duplicate. Employee name can also be duplicate, but the combination of employee ID and employee name must be unique. For that, let's use the constraint keyword, and we need to say primary key. I mean, this is the name. You can give any name, but this name should be unique. So I am saying primary key employees employee ID, and also want to add employee name. I will specify the employee name here also. Basically, I'm saying the combination of these two columns should be unique in my table. Let's try to create this and see if it is working. It has been created successfully. Let's try to insert data in our employees table. So here we were inserting data. So let's say we are executing this statement. Mark is coming. We executed, it got inserted successfully. Let's say I want to add Peter with the same employee ID, right? 101, and name is Peter. And if I execute this, this also got inserted. You see, employee ID is duplicate 101 101, but the name was different. Here it was Mark, and in the second time it was Peter. If you see the records now, you see we have 101 Mark, 101 Peter. Let's insert the third row. Let's say Peter 103, and let's say we will add 103, and this time I'll say Peter. We have the employee ID same, right? Because we already have 103 in our database. So this is there. We also have Peter in our database who is having 103 as the employee ID. Basically, this combination is not unique. This combination is already present in our database. If I execute this insert query, we are violating the primary key constraint. We are not allowed to add duplicate combination again in our table. We already have this 103 Peter. We are not allowed to insert it again, right? So this is how composite primary key will work. And composite primary key will not allow null values. Let's see that in action. Let's say null here. If I execute this, you can see we cannot insert null because it is our primary key, and also we have declared this as not nullable. Let's say this is 104, and the employee name this time I will give as null. Let's try to insert this and see what happens. You can notice we are not allowed to give null in the employee name also, because this is our primary key. Not exactly the primary key, this is the part of our primary key because it is part of our composite key, right? We have declared employee name in our primary key. So we cannot insert null for employee name also, right? So let's give some value name Sarah and try to insert again. So we are able to insert the data, correct? So this is how composite primary key will work in SQL Server. In this video, let's understand about identity column. Identity column can be used for columns for which you want to generate the data automatically. Columns like employee ID, user ID, these kind of columns can be set as identity column so that you don't have to provide the ID values. Those can be auto-generated by the SQL Server. Let's understand this with an example. Let's create a table customers. I am creating this simple table customers and I am adding two columns ID and a name. Let's create this. Normally when you will be inserting data in this, what you will do, you will say insert customers and then you will provide values for ID and name. So this is how you will insert. You will provide the ID and then the name, right? Let's execute this. Instead of providing these values manually, these can be auto generated by SQL Server. When creating this table, I need to specify their identity, right? And then I need to specify from where these values should start. If you want to start your values from 1, like you want to add 1 2 3 4, you can start from 1, right? And then you need to specify the increment after each insertion, how much the identity should increase. If you want to have a continuous values like 1 2 3 4, then you need to increment by 1, right? But you can choose whatever is feasible for you. For this example, let's start it from 500 and let's increment by 5 each time we are inserting a row in it. Okay, so this table is already there, so let's drop this table first. Okay, table has been drawn. Now let's recreate this table, and this time we are specifying ID as our identity column. Let's execute this. Table has been created. Now when inserting the data, you only need to specify the name. You don't have to specify the value for the ID column. Let's see. See, I am not specifying anything for ID. I am just specifying the customer name. Let's execute this and let's see the data in our table. You can see here ID 500 has been automatically assigned to Mark. If you insert one more record in your table, let's say Peter, execute this and see the data again, you can see 505 has been assigned to Peter. So we have started with 500 and after each insertion, the value will be incremented by 5 because that's what we have defined here. Let's enter one more, Sarah, and this time the value should be 510. Let's see the data. We have the 510 here, right? So this is how you can use identity column in SQL Server. And guys, normally these identity column we will use on primary keys, but they can be used on any column, right? So let's see how we can use this as a primary key also. So let's drop this table, and so the logic is very simple. So this column will be my primary key column also, and I'm specifying the identity also on this column. Now let's create this table and try to insert the data. Data has been inserted, and if you see here, again we got the same result, but this time our ID column is also our primary key column. So this is how you can use identity column in SQL Server. In this video, let's understand how we can insert data in an identity column. So I'm creating this table customers that is having ID, that is of identity. I'm starting from 10 and I'm incrementing by 2 here, right? And the second column is name. Let's create this table. Let's insert data. So I'm inserting data in my customers table. One row affected. Let's see the data, right? So we have the ID 10 and mark here. Let's say I want to insert one more row in my table, and this time I want to specify the ID also. I want to specify ID as 15 for Peter. Let's try to insert here. You can notice we are getting this error. We are not allowed to add data in the identity column. For that, we need to switch this identity insert to on. So let's set this identity insert to on. To set this, we need to execute identity insert. Then we need to specify on which table we want to switch it on. I want to switch it on customers table. So let's say dbo.customers, and I want to set the value to on. Okay, let's execute this. And again, let's try to insert this row. Okay, again, we are getting the error. We have already specified the identity insert as on, but there is one more condition. We need to specify the column list also. So guys, whenever you are trying to insert data for an identity column, there are two conditions. First, you need to specify the column list, and you need to specify identity insert as on. Let's specify the column list also. So I need to specify ID and the name, right? Because these are the two columns for which I am specifying the values, right? Let's try to execute this query again. Data has been inserted this time. Now let's see the data. We have the Peter, and this time we are able to give our own custom ID instead of generating it automatically. So we have the ID as 15 for Peter. Now let's try to add one more row, and this time let's say I want to add Sarah. Let's execute this and see we are again getting the error. Because we have set the identity insert to on, we have to switch it off so that SQL Server can generate the ID values and insert them, right? So let's switch it off again, and now again try to insert Sarah. Data has been inserted. Check the data. Now you see Sarah has been inserted, and the ID that is assigned to Sarah is 17 because last ID was 15 and the increment that we have specified is 2. That's why ID 17 is assigned to Sarah. That's it for this video. In this video, we have seen how we can manually insert data in an identity column. Hello and welcome. In this video, let's see how we can add an identity column on an existing table. So I have this table customers. I have created this table without any identity column. Let's see the data here. So I have around 20 rows here, and I have this customer ID. Let's see how we can add an identity column in this table. Basically, there are three approaches. First one is simply add a new column in this table. You need to alter your table. Let's specify the table name. And then you need to let's add the new column with the name customer sequence. This is of integer type, and after specifying the data type, I can specify identity. Let's start from 10 and increment by 2. Let's execute this. Now let's check the data again. We have the identity column, right? Let's order it by customer sequence, and you can see we have these IDs here which are automatically generated by SQL Server and inserted into the customer sequence column. So this is one way, but the disadvantage of this approach is now our table structure has been altered. Now we have one additional column, customer sequence, and this can break any existing APIs or procedures that you are using on your table. Now let's see the second approach. How we can add an identity column without actually changing the structure of the table. We can drop this customer ID column and then re-add this with the same name, but that time we will add it using the identity. Let's see how that can be done. So let's drop the column first. So let's use alter table again, and we need to drop. What we need to drop? We need to drop a column. Which column I want to drop? I want to drop the customer ID. Okay, let's execute this. Command has been executed, and let's drop this customer sequence also because we don't want this also. Right, let's see the current table structure. Current table structure looks like this. There is no customer ID, there is no customer sequence. Now let's add our customer ID back to our table. So I will say alter table customers and add, instead of customer sequence, I will say customer ID, right? Let's add this column again, and let's see the data again. You can check here. Now we have our customer ID again in our table, and we have some automatically generated IDs also in this. So this is second way. In this approach, we have not changed the number of columns in our table. We have kept the structure same as the old one, right? Only thing is we have moved the customer ID from first position to the last position. Now let's see the third approach, in which what we will do, we will keep our existing data also, because if you notice here, we have now randomly generated the customer IDs. We have lost the customer IDs that were already there. So let's see how we can keep our existing data also and keep the structure as it is. For that, we need to create a new table and move this data to that new table and then bring it back to our old table. Let's see how that can be done. First, let me recreate this table back so that we will have the customer ID at the first position. So let me drop this table. Now let's recreate this table. Let's insert the data which we were having earlier. Let's do select star from the table. We have this data now. Now let's see how we can add an identity column and without changing the structure and without losing the data. First, we need to create one more table with the same structure so that we can copy the data from this table to a backup table. So let's create one more table and let's call it customer backup. Let's create this table. Table has been created. Now let's move the data from customers table to customer backup table. For that, we need to say insert into customers backup, and what we are saying, select star from customer. So whatever data will come from this select statement will be automatically inserted to customers backup. So let's execute these two lines. The data has been moved to customers backup. It is not exactly moved, it has been copied to customers backup. Now we have data in customers table as well as we have data in our customers backup table. Now what we can do, now we can drop this customers table. We don't need this because we have already copied the data to a backup. Now let's recreate the customers table, right? And I will specify the identity here, and I'm giving it 1,1. Let's create this table back. Now we have our customers table with identity column, but currently we don't have any data. Now let's see how we can copy data from backup table to our actual table. For that, we can use the same thing, insert into customers, and I need to say from which table I need to copy. I need to copy it from the customers backup table, right? If I execute this, I will get the error because if you remember, we cannot directly insert in identity column. First, we have to switch on the identity insert, supply the column list, and then only we can insert the data in an identity column. Let's first try this and see the error. Right, we are getting the same error because the identity insert is not on, and we have to specify the column list also. So let's do this thing and then try to insert. First, let's switch on the identity insert to on, and we need to specify the table. On which table I need to do this? I want to do this on my dbo dot customers table. Right, let's do this, and then I need to specify the column list. So let's get the column list by pressing alt plus F1. I will get all the details about the table. I'll copy this list from here and I will supply with my table name within the brackets. I think we are good to go. Now let's try to copy the data again. Data has been copied. Now if I see my customers table again, now I have the customer ID, and this time customer ID is an identity column. You can verify that while going to the details again by pressing alt plus F1. You can scroll down and you can see the identity column is customer ID. We're starting from 1 and we are incrementing by 1. After that is done, what you can do, you can first of all, you can switch off the identity insert, because now we don't want to insert data manually in this table. I want SQL Server to generate the IDs and take care of the customer IDs. Let's switch it off, and then we can drop this customer backup table also, because now we don't need this. We have already copied all the data from this table to our actual customer table. So let's drop this table as well. So this is done. So guys, this is how you can add an identity column in an existing table in SQL Server. In this video, let's see how we can get the last generated identity value using the scope identity function. So I am creating this table users, where first column is ID and the second column is name. And guys, if you can see here, name is a keyword in SQL Server. If you want to show the name as same in the black text in SSMS, what you can do, you can escape the keywords using the square brackets. If I put my name in square brackets, this will also do the same thing. Let's create this table. Table has been created. Now let's insert data in this table. So let's insert the data. Data has been inserted. Now let's check the data. We have the data inserted and the ID that is inserted is 10. Now let's say I want to know which ID was generated by SQL Server when inserting the data in the table. Let's say I'm inserting. At this time, after inserting the data, I want to know which identity was generated, so that I can use that identity and give the message back to the user. Maybe I can send it back to the API saying like this customer ID or this user ID is created, right? So to get the generated identity, what we can do, we can use an inbuilt function of SQL Server, that is scope underscore identity. So using this one, we can get the value. Let's select this. Now let's insert the data and select this scope identity. Execute this. You can see now we are selecting 17 because 17 was generated when inserting Peter in the table. You can see in the table also 17 has been inserted. Now let's say I'm adding one more record. Let's say Sarah. Let's execute these two lines. First one is inserting, and second one, basically this scope identity will give us which identity was generated recently. So if I execute this, I'll get 24, right? Let's see the table also. We can see 24 has been inserted here. So guys, this is how you can easily get the recently inserted identity value using the scope underscore identity function in SQL Server. In this video, let's understand what is not null constraint. So I'm trying to create this table, employee table, and these are the four columns I want to add: employee ID, employee name, employee email, and employee salary. Let's say I want to keep my employee ID as auto-generated. For that, I can define this employee ID as identity column, and also I want to make this as primary key. So I can assign primary key also to this column, which will make sure nobody is allowed to insert null in this column. By saying identity means it will auto generate the values for employee ID, and by saying primary key I am saying this value will be unique. I cannot add duplicate values to my this column, and I am also saying this column cannot have null values. So by default primary key cannot have null values. Similarly, if I want to make my employee email as not nullable, for that I can use not null constraint. To make column not nullable, we can simply add not null in front of the column name. Like this we can add, and if I create my table with this syntax, this will make sure our employee email is always having some value. SQL Server will not allow null values here. Let's create this table. Table has been created. Now let's try to insert a record in employee table. Give a valid name here, and let's try to give null as our email address, and let's provide some salary to our employee. Let's try to insert this record. You can notice we are getting an error here. That is because we cannot insert null into column employee email because this column has declared as not null. However, let's say, so I am giving some email address here, but this time I will make my name as null. You will notice by default SQL Server will make all our columns as nullable. So this statement will be executed without any issues. Let's execute this. You can notice one row affected, and if I do select start from employee and see the data, you can notice the employee ID 2 is given to Mark and employee name is not available because we have inserted null. Okay, let's say you want to make your employee name also as not nullable because employee will always have a name, right? So it doesn't make any sense to have employee name as null. So let's see how we can make our employee name also as a nullable column. So for that, we need to use alter table statement, right? Because the table is already created. If the table is new, then you can use this syntax and make your column as nullable. But if your table is already created, then you need to use alter table statement. So let's use that. I will say alter table and I will specify the table name, that is employee. And then I need to say alter. I want to alter a column and the name of the column is employee name. I want to keep the same data type where 255, but this time I want to make it also as not null. Let's try to execute this and see what happens. If I execute this, you will notice we are getting an error here because in our table we already have a null value on this employee name. So we are not allowed to make this column as not nullable. First of all, we need to remove this record where we have the employee name as null. Then only we can make our column as not nullable. So let's do that. Let me remove the record. So I am deleting this record. Let's delete this. Now let's again try to alter the column. Now the column has been altered successfully. Now if you try to execute this statement again where the name of the employee is null, you will get the error. Let's see. Execute. You can see I am not able to insert null here because now our employee name is also not nullable. You can verify that by selecting the table and pressing Alt plus F1 key of your keyboard. This will fetch all the details about the table, and in this section you can see employee name and you can look for column that says nullable. Now it says nullable no, right? Because we have made our employee name also as not nullable because our employee ID is primary key, so this column is also not nullable. Only nullable column now is employee salary, and we see yes here, right? Let's provide some name to our employee. Our record has been inserted. Let's see in the table also. So we have our mark employee with the email address and the salary. So guys, this is how you can use not null constraint in SQL Server. Let's understand how we can use check constraint in SQL Server. So I am creating this table employee and I am having three columns: employee ID, employee name and gender. Let's create this table first. Now let's try to insert record.
So I am trying to insert these two records in my table. First one is Mark and I am inserting gender as male here. Right, I am executing this and this got inserted. Second record I am creating Peter, and if you notice I have misspelled the gender here, but if I try to execute this will also get inserted without any issues. Now let's see the data in our table. You can notice here now I have the employee Mark with male as gender and Peter also with male, but this time the incorrect data has been inserted in our table. To avoid these kind of issues, we can use check constraint. We can add some validation to our gender column and make sure only valid data is getting inserted or allowed in the table. Let's see how that can be done. Let's drop this table first. Now, while creating this table, I can say constraint and I can give a name to my constraint because this is a check constraint. Let's say I will start with CK and here I want to add this constraint on gender column. So I will just specify the column name here and here I can use check keyword and I can say employee gender should be in and I can specify the valid values that it can accept. So what I'm doing here, I'm creating a constraint, and this is the name of the constraint that I have given, and this can be anything. Then I have used the check keyword to create a check constraint. And what I'm saying, employee gender value should be in these three values. If there is anything value that is coming that is not from these three values, we will get an error. Let's create this table and now let's try to insert this data where the gender is male. So this is a valid data, so we will not get any error. But when we try to insert Peter, where we have misspelled the male as M-A-A-L-E, if we try to insert this one, we will get an error here. Because if you read this error message here, it says check constraint this has been failed. And why it has failed? Because the conflict occurred in database, this database name table this and employee gender is the column. So the value that we have specified here is not currently passing through this check constraint. This is how you can make sure your table is always having valid data. Right, so this is the one syntax that you can use for check constraint, but there are others also. Let me show you those as well. So let's drop this table and instead of using this syntax, what you can do, you can copy this from here. Let's remove this and you can specify this in front of the column on which you are adding the constraint like this, and you can create the table like this also. Right, this will also do the same thing. If you try to insert some invalid data, you will get the error. Right, so this is also one of the syntax that you can use to add check constraint. And one more syntax I want to show you here. Let's see syntax of this table. So I am trying to create persons table and the check constraint I am giving here age is greater than 18. What I am saying here, whenever I am trying to insert in persons table, the age of that person should be more than 18 or equal to 18, right? So let's create this table and try to insert data in this. So I'm trying to insert a data in my persons tables and the age that I have specified is 17. Let's try to execute this. I'm getting the error because age cannot be less than 18, and if I change my age to 18 and try to execute this again, this time I'm allowed to insert data in my table. So this is one more syntax that you can use to add some validation for a column. That's all for this video. In this video, we have understood how we can add check constraint in our tables and how we can make sure we are only inserting valid data into our SQL Server tables. In this video, let's understand how we can use check constraint with multiple columns. Let's say I'm trying to create this table and on this table I want to make sure the age that user is providing is always greater than or equal to 18. Along with the age, I also want to make sure the person that we are adding to this table is having city as New York. We don't want to add any record that is not having city as New York. For that, we can use check constraint. So again, let's use the syntax that we have seen earlier. We can use the constraint keyword. Let's specify the name of our constraint and let's use the check keyword. And here we can specify the check that I want to perform. The first check that I want to do here is age of this person is greater than or equal to 18, and I can specify one more column here using the and keyword, and I can specify the city here should be New York. So this is how I can specify a check constraint that involves multiple columns in it. Let's create this table. Table has been created. Now let's try to insert some record in our persons table. I am saying employee ID, last name, first name, and the age is 17 and the city I am specifying is London. Now let's check with our check constraint. Is my age greater than or equal to 18? No. Is my city is equal to New York? No. So both the conditions are failing. If I try to insert this, I will get the error. Check constraint has been failed. Now, if I change my age to 18, this condition is true, right? If I try to execute this now, I will again get the error because the city is not New York. City is still London. So let's correct this also. And now try to insert this record. Now the record has been inserted. And if we check the data in the table, we can see the data has been inserted as expected. So this is how you can use check constraint with multiple columns in SQL Server. Hello, in this video, let's understand what is a foreign key in SQL Server. A foreign key is a column or a set of columns that allows us to establish a link between two tables. If you see in this example, we have two tables, customer and orders. And we are somehow connecting these two tables with help of a foreign key. If you notice here, we have this customer ID in the order and we have this ID in this table also. So the customer ID is primary key in our customers table, but the customer ID will be a foreign key in our order table. This allows us to have a referential link between two tables, and this is very important to maintain the integrity of the data. Let's see with an example why a foreign key is important in database. Take a look at this example. I am creating a table customers and I have these columns, and the main thing you need to notice here, I have this customer ID that is my primary key in my customers table. So let's create this table. Let me select a database. So I will select my demo new database. Let's create this table. Now let's insert some data also in this table. Now let's create one more table. So I am creating this second table with the name customer orders, and it has ID as the primary key. So this is the order ID, right? And we have order date, customer ID, basically the customer who has placed this order, correct? And we have amount, spelling will be amount, okay? So this is my second table. Now I'm creating this table also. Now we have two tables and currently there is no relationship between customers and customer orders. Let's say I'm inserting some data in my customer orders table also. So I am trying to insert these three records in my table. So what I'm doing, I am specifying the order ID 1, 2, 3, and I'm specifying customer IDs 1, 2, 3. And we have customer IDs 1, 2, 3 in my customer table also. So let's insert this. And now let's see the state of our two tables. So let's select the data from both the tables. So if you see this data, we have customer ID 1, 2, and 3, and we have customer ID 1, 2, and 3, right? So the data is correct. Now let's say someone is trying to insert one more record in customer orders, and this time let's say the order ID is 4, so that is correct. But the customer ID that they are specifying, let's say they are specifying 15. Do we have any customer with customer ID 15? No. The only customers that are available are 1, 2, and 3. If I execute this,
one row affected, and if I see my data now, I have customers with 1, 2, 3, and now I have one more order number 4, which is placed by customer ID 15. If I want to know who has placed this order, there is no name of the customer and there is nothing else linked to this customer. So the data is now corrupted. Now someone has created an order for a customer and that customer is not available in our database. This is why foreign key is important. Using foreign key, we can avoid such kind of issues. So let's see how we can link these two tables, customer and customer orders, so that we can only insert in customer orders if that customer is available in the customers table. So let's first drop these two tables. Okay, so I'm dropping both of these tables. Right. Now let's again create the customer table. Right, we don't need to make any change in here. Let's insert the data in the customer table. Now let's create the customer orders table. Here I want to specify the customer ID that is this column should be linked to the customer ID column present in the customers. Basically, I want to make this as a foreign key. To create a column as a foreign key, what we can do, we can simply use the foreign key keyword. So what I can say foreign key here, and then I need to specify to which column it will refer. I want to make this key to refer to customers table. So I can say customer ID is a foreign key and this is referencing. So I will use the references keyword, and after references, I need to specify which table I need to look for. I need to look for customers table, correct? And within the brackets, I need to tell to which column I need to refer. I need to refer to customer ID column. So by doing this, what we are actually doing, we are creating a relationship between customers and customer orders. Basically, if this is the case, no one will be able to add a incorrect customer ID in customer orders. Let's see this with an example. Let's create this table again. Now let's create this data. Data has been inserted. Now let's see till now what we have. Again, we have 3 rows in customers 1, 2, 3, and 3 rows in orders customer ID 1, 2, and 3. Now let's say someone is again trying to enter the customer ID 15 that is not available in customers table. So let's see what will happen if I try to execute this now. If I execute this now, I will immediately get the error. Insert statement conflicted with the foreign key constraint. So the foreign key constraint is now in place, right? This is the constraint name, and this is the table on which this foreign key was looking, and this was the column that this foreign key was referring. So now we can only add a customer ID 15 if the customer ID 15 is present in customers table. Other than that, it will not allow any other customer ID. So now let's create this customer ID 15 and check if we are able to insert after that or not. So I will create one more customer and I will give customer ID as 15 here. Let's give some name and let's execute this. Now we have customer ID 15 in our database. You can verify we have customer ID 15 present in customers table. This time if I try to create an order for customer ID 15 here, this will get successful, right? One row affected. If you see the data, so we have customer ID 1, 2, 3, 15 and 1, 2, 3 and 15 here, right? So this is how foreign key works in SQL Server. In this video, let's see what will be the behavior if we try to update or delete foreign key data. In the last video, we have established a relationship between customers and customer order table. Basically, we have made our customer ID in customer orders table as foreign key. In this video, let's see what will be the behavior if we try to update or delete customer ID in customers or customer order table. So let's say I will update my customer ID 15 to something else in customers table. So let's write a update query. So what I'm doing, basically I am updating my customer ID to 20, where customer ID is equal to 15. So what will happen if I try to do this? Because this column is linked with this column, and if we have tried to update data here, this will give us an error. This is not allowed. Why this is not allowed? Because if we make this customer ID as 20, it will make this order 15 is an orphan order. We will again not find any customer with customer ID 15. Let's try to execute this and see the behavior. If I execute this, I will get this error. Foreign key constraint is again failing because data is linked in customers and customer order table. If this is updated to 20, it means this order will become invalid and SQL Server will not allow this by default. We will see how we can change this default behavior, but currently if I try to update simply, it is not allowed. Now let's see if we are allowed to update in customer orders table. My table name is customer orders, and the customer ID column I'm trying to update, right? So I am trying to update this column here. Let's see if this is allowed or not. We are again facing the error because the foreign key constraint is again in place and we are not allowed to update in this case also. And same thing will happen when you try to delete also. Let's see that also in action. So the delete will work in some different way. So when you try to delete from customers table, it will not be allowed because that will create this record as invalid. But if you try to delete from customer orders, it will be allowed because there can be a case where a user or a customer has not placed any order. Correct? That is also can be the case. It is not mandatory to customer IDs to be present in customer orders. But the reverse is not true. The customer IDs that are present in customer orders should be present in customers table. We can see this here. So if I try to delete from customers, I will get the error because 15 is currently referenced in customer orders table, right? So we are not allowed to delete customer ID 15. But if I try to delete customer ID 15 from the customer orders table, it will not give any error because, as I said, customer ID 15 might not have placed any order. In that case, there will be no entry in customer orders table. Let's try to delete that and verify it has been deleted successfully. You can see the data again. Now we have customer ID 15 here, but there is no order placed by customer ID 15, which is absolutely fine. So this is the default behavior of foreign key in SQL Server. In the next video, we will see how we can change this default behavior by using some cascading when doing the update and delete operation. In this video, let's understand the behavior of foreign key with cascade keyword. In the last video, we have seen the behavior, the default behavior of foreign key when we are trying to update or delete the data. Now, let's again drop these two tables and we will create this table with cascade keyword. Okay, so the tables are deleted. And now let's again create the customers table. Now let's insert the data. Now, while creating the customer orders, I want to specify the behavior of foreign key, and that can be specified right here. So what we can do, I can specify on update cascade and on delete, let's say no action. So what I'm doing here, right? What I'm saying on update cascade the change. Let's create this table and let's see with an example how this will behave. Okay, so I've created this table and let's insert the data also. Let's see the data. Now we have these customers and we have the customer orders. Now, earlier when we were trying to update this customer ID 15 to 20, it was giving us the error. The foreign key was not allowing this to happen. But when I have specified on update cascade, what will happen if I am trying to update this here? It will cascade this change to customer orders also, right? So the customer orders table, the 15 will become 20. Let's update this, and now let's again see the data. So the customer ID has become 20 here, and it has also updated in the customer orders. So basically the change that we did on customer table is cascaded to customer orders table, right? So this is how you can use on update cascade. But what we have specified for on delete we have specified no action. This means the default behavior. If we try to delete the data where the customer ID is 15, let's say 15 is not available now. Let's say I am trying to delete the customer ID 20. I will get the error because for this default behavior is still applicable. And we can make this delete also as cascade. But before saying that, let's see what will happen if we try to update in the customer orders table. So let's say I have this customer ID 20 here and I want to update it to 15, right? And we don't have a customer ID 15 here. Let's try to update this and see what will happen. We will get the foreign key constraint error. So the cascading will happen from parent to child. It will not happen from child to parent. So if you update from customers table, it will cascade to the child table, that is customer orders. But if you try to update in customer orders table, it will not cascade to the parent table, right? This is also important to know here. Okay, now let's discuss the delete cascade also. So I have specified on delete, let's say this is also as cascade. Okay, let's drop this table and create it again, right? So let's create this table again. This time on both I specified cascade. Table has been created. Now let's insert some data. Okay, data has been created. Now let's see the data. Okay, so I have 1 2 3 here and I have 1 2 3 here. Let's create one more order for customer ID 20, right? Let's again see the data. We have 1 2 3 20, 1 2 3 20, right? Now let's say I want to delete the customer ID 20 from my customers table. What will happen in this case? In this case, it will cascade this change to customer orders and delete the record from customer orders also, right? If we are deleting it from customers, I mean from the parent, this operation will be cascaded to the child table also. Let's delete this one row affected, and if you see the data again, the data has been deleted from both the tables, from the parent as well as from the child. So this is how on update cascade and on delete cascade will work in SQL Server. In this video, let's understand what is a unique key in SQL Server. You notice here I am creating this table person and I have four columns here: ID, that is primary key in my table, I have name, I have email address, I have passport number, and I'm trying to insert these three records in my table. ID is my primary key, so I cannot provide duplicate values for my ID column. I will change these ID columns to 2. Let's say this is 3. Let's first create this table and now try to insert this data in our table. So the data has been inserted. Let's check the data what we have inserted. We have inserted person ID 1, Mark Miller, having this email address mark@abc.com, and the passport number is S101. But if you notice, this same passport number is used by Peter Parker also. In a real case scenario, this can never happen. Every individual will have their own passport number. So this duplicate entry for the passport number is not correct. And if you notice the ID 2 and 3, the email address is duplicated. This can also not happen. In real world, each person will have their unique email address. Two person cannot share one email address. We don't allow two persons to use same email address. The data that we have inserted for email address and passport is not correct. We have duplicate data here. We know we can avoid duplicates by assigning that column to a primary key, but we cannot have multiple primary keys in a table. To handle this kind of situation in SQL Server, we have something called unique key. So what we can do, so while creating this table, we can define unique keyword in front of the column that we want to make unique. So let's do that. So we can simply use this unique keyword in front of the column for which we don't want to allow duplicate values. Now let's drop this table and create this again with unique constraint. Table has been dropped. Now let's recreate this table. Enter the first record, that is Mark Miller, and if we see we have this record inserted. Now let's say someone is trying to insert this second record where the passport is duplicate, because we already have a passport number with the same value. Let's see what will happen. When I execute this insert query, you will notice we are getting this unique key constraint violation. So SQL Server is now not allowing any duplicate values for this column. User has to provide a unique value, then only we can insert the data for this column. So let me change this passport here to pass 102. Let me try to insert now. This time it got successful. Now let's see the data. Now we have Peter Parker with this email address. Now, let's say we are trying to insert this third record where the email address is duplicate, because we already have this email address and we have this pass 102 that is also duplicate. So for now, let's change this to 3. Now the email address is duplicate. Still, if I try to execute this will fail. This time this duplicate value peter@abc.com is not allowed. We need to change the email address and provide a unique value. So let's change the email address also. Now I have updated my email address to this. Now let's try to insert, and the data has been inserted. If you check the data, you can see here we have 3 records, and all 3 records are having unique email addresses. There are no duplicates, and same thing is for passport number. All passport numbers are now unique. That is because we have defined this unique in front of our columns. So this will basically create a unique constraint on the table. You can verify that by going to the column here. Let's expand tables and expand this person table and go to keys. Here you can see there are 3 keys available. One is primary key, and these are the unique keys that are added in this table. Unique key for this column and unique key for this particular column. Okay guys, so this is how you can use unique key in SQL Server. Hello and welcome. In this video, let's understand how we can create a unique key that includes multiple columns. Let's look at this example. I am trying to create this employee table, and I have 3 columns here: ID, first name and last name. Let's create this table, and I am inserting 3 records in my table: Johnny Gibson, Johnny Chapman, and the third record is exactly same as the first record, Johnny Gibson. Let's execute this, and if you notice at the data here, we have this first and third records are exactly same. Only the employee ID is different. What we want to do in this case, right? We don't want to allow user to insert duplicate records where the first name and last name is same. So the first name can be duplicate. I mean, Johnny and Johnny can have duplicate values. Last name can also have duplicate values, but the combination of first name and last name must be unique. Let's see how we can provide a unique key constraint for this kind of scenario. Okay, let's drop this table first. So let's say constraint here. Now we need to provide a name for our constraint. I will provide uq underscore first name underscore last name. Then I need to specify which type of constraint I am adding. I am adding a unique constraint. And then I need to specify on which columns I am adding this constraint. Because I am adding it on multiple columns, so I need to provide this brackets, and within the brackets I need to provide first name, comma, last name. Right, now let's try to create this table again. Table has been created. Now let's try to insert first record, Johnny Gibson. This is getting inserted without any issue. Let's try to insert second record where the first name is duplicate but the last name is different. So this should also be allowed. Let's try to insert this also. This is also getting inserted successfully. But now the third record where the first name and the last name is not unique, meaning this combination already exists for this particular employee, this should fail with unique key constraint violation. Let's execute this, and you can see this unique key constraint, and this is the constraint name which we have specified here. This is getting violated because this duplicate value that we're trying to insert is already available in the table. Right, so let's try to change this last name and try to execute again. This time it is getting successful and we can see our data. So this is the data we have just inserted, and to prove that we can have duplicate values for last name also, let's try to insert one more record where employee ID is 4. Let's change the first name here, and I'm giving the same last name. This should also work fine because the combination is unique, right? So this is also getting inserted. So guys, this is how you can use unique constraint with multiple columns. In this video, let's understand what is the difference between a unique key and a primary key in SQL Server. This is also one of the most frequently asked interview question. So let's get started and understand the difference between these two. On this table, you will see all the differences between a unique key and a primary key. First one, let's see the purpose. The purpose of primary key is to uniquely identify each row in a table, right? But the purpose of unique key is that ensures uniqueness of the column values. The second difference is we can only have one primary key in a table. But as we have already seen in the last couple of videos, we can have multiple unique keys on a single table. Primary key will not allow any null value, but unique key will allow one null value. Let's see this in SSMS also. Let's have a look at this example. I am creating this employee table where I have this unique key on email and I have this primary key on ID column. Let's create this table. Table has been created. Now I am trying to insert one for the primary key and null for the email address. Let's try to execute this. Data has been inserted successfully and we are able to insert null for our email. Let's see the data in the table. We have one record where the email address is null. Let's try to insert one more record where I will give 2 as my primary key and I'm trying to insert null again. Let me change the name also. I'm trying to insert one more null value for my column. Let's execute this. I'm getting the error because the unique key will not allow more than one null value. But you cannot add any null value for the primary key. Let's say I'm adding primary key as null here and I'm changing the name as Pam and I'm providing some email address here. Let's try to execute this. We are getting the error because we cannot insert null into the column ID because this is a primary key column and we are not allowed to insert any null value in the primary key column. So this is the main difference between the primary key and unique key. Unique key will allow one null value, but primary key will never allow any null value, right? Duplicate values, there is no difference. In primary key and in unique key, we cannot have duplicate values. Index. Guys, we have not understood what are indexes, but for this difference, you can understand when you're creating a primary key, it will automatically create a unique clustered index on the table. But when you're creating a unique key, it will create a unique non-clustered index on the table. for that particular column. In case of foreign key, there is no difference. The primary key as well as the unique key can be used as a foreign key in other tables. So there is no difference when it comes to foreign key. So the primary key is used as main identifier. So whenever you want to identify a record in a table, you will normally use primary key instead of unique key. Primary key can be composite as well as unique key can also be composite. We have seen in the last video how we can create a composite unique key constraint type. So the primary key is a table level constraint, whereas a unique key is a column or a table level constraint. So the typical use of primary key is like employee ID, order ID, person ID. So whenever you have a unique identifier, for those you will add your primary key. Unique key, as we have seen earlier, can be used for columns like email, username, PAN card number, passport number, or maybe a Aadhaar number. So these are the few differences or the behavior of primary key and unique key in SQL Server. In this video, let's understand what is the difference between a primary key and a foreign key. So this is also one of the most frequently asked interview question. So let's get started and understand this. First of all, primary key is basically used to identify each row in a table uniquely. If you have a primary key, you can easily identify a particular row in a table. Whereas the main purpose of foreign key is to create a relationship between two tables. If you take a look at this example, here I have this department table and here I have employee table. And if you notice, the department ID is primary key here and the department ID that we have in employee table is a foreign key that is referring to department table and it is referring to the department ID column in department table. So basically we are connecting employee and department tables with help of this foreign key. And the second difference is we can have only one primary key in a table, but we can have multiple foreign key in a table. Third difference is we can never have null values in primary key column, whereas we can have null values in foreign key column. Let's understand this with an example. Let's look at the same example. We have this employee and department table. Let me create the department table first. Now let's create the employee table. I can insert null for my foreign key. If you notice, I am inserting null for my department ID column. If I execute this, there will be no issue. One row affected. We can see the data also. Department ID is our foreign key, but we are still able to insert null in this column. Whereas if I change my primary key as null and try to insert this record, I will get the error because we are not allowed to insert null for a primary key column. And the fourth difference is in primary key column, you are not allowed to insert duplicate values, whereas in foreign key, we are allowed to insert duplicate values. Okay, so let's change this to 2 and we are allowed to insert multiple null values also in foreign key column. If I execute this one, this will also get successful. And if I check my data again, I will have two null columns here, right? So there are two null values. And let's add some valid values in department table. I am adding department ID 1 and 2. Let's execute this. Now, I am adding this third employee. I am saying department ID as 2 here. This will get insert. And if I try to insert one more row, let's say this is employee ID 4 and the name is John, and I'm trying to insert department ID 2 again. This should also get insert without any issue because we are allowed to insert duplicate values in foreign key column. So that's it for this video guys. In this video we have seen what are the differences between a primary key and a foreign key column in SQL Server. In this video, let's take a look at select statement and let's see how we can use top and distinct keywords along with select statement. So we have written select statement multiple times in this video series. So basically we can say select and then we can say star and then we can specify from keyword and then we can tell the table name. So what basically this is doing, when we are saying select star, it means select everything. When I say everything, it means every column. So when I use this select star, it will take all the columns from this table. From which table? Which is specified after from keyword. So from employees table, it will select all the columns and it will select all the data. So if I say select star from employees and execute this, I will get all the records that are available in my table, and I will see all the columns that are available in my table. So if you want to get all the columns, you can use select star. But let's say you want some specific columns. Let's say you only want employee ID and the first name. So what you can do, instead of saying select star here, you can say employee ID, first name. If you say select employee ID, comma, first name, it means you are specifying some specific columns here, and the SQL server will only return these two columns. If I execute this, you can see I am only getting two columns, right? So this is how you can get specific columns from SQL Server, right? And if you don't want to type all the column names here, what you can do, you can right click on the employees table here, and you can say script table as, and you can go to select to, and you can say new query window, right? If you say this, it will open a new query window and it will write the select statement for you, and all the columns will be mentioned here, right? You can execute this here and you will get the same result, right? If you notice here, this select statement is having this dbo.employees. So what is DBO? DBO basically is the schema name in which we have this employees table. Guys, we have not understood what are schemas. So we will understand what are schemas in the later videos. But if you see this query, we are having this use demo. It means we are using demo database and then we are executing this query. What we can do, we can put this demo database instead of here. I can put it, let's copy this and put it here in front of the schema name, and let's remove this from here, right? So this demo dot schema name dbo dot table name, this is called the fully qualified name for the table, meaning we have specified everything in which table is belonging, right? So it belongs to demo database, and within the demo database it belongs to dbo schema, and in the dbo schema we are targeting our employees table. So if I execute this, I will get the same result. But the benefit of using a fully qualified table name is, even if you are in your master database, let's say you are in your master database, right? And if you execute this query, this will still work because we have used a fully qualified table name here. And if I remove this, let's say I will remove this demo here. And if I try to execute now, I will get the error invalid object name employees, because within the master database, we don't have any table with name employees. In the demo database, however, we have this table, right? So this is the use of fully qualified table name. One other thing I want to mention in this video, right? I want to show you how you can use top keyword. Let's do select star from employees again and execute this. I'm getting 10 rows. Let's say this table is having a million records. If you do select star from employees, it will select all the records. But let's say you just want to see some sample data. You just want to see some top 2 or 3 rows. So what you can do for that, along with the select, you can specify the top keyword. You can say top, and then you can specify how many rows you want to pick from the top. Let's say I want to pick top 3 rows, right? So what I'm saying, select top 3 rows and select star. I mean, I want to select all the columns. If I execute this, as expected, I'm getting top 3 employees here, right? And here also I can specify the column names. If I want to specify employee ID first name, then it will only pick the employee ID and the first name from the first 3 rows. And this top 3, I can say top 5, then it will select top 5 rows, right? One more thing you can use here, right? You can specify a percentage. Instead of specifying an actual number, you can specify a percentage of rows that you want to pick from the table, right? So we have 10 rows here, and let's say I want to pick 70% of the rows. So what I can say, top 70, I can say percent. When I do this, it will calculate the 70% of the total number of rows. So it will be around 7 rows and pick that. Not around 7 rows, it will be exactly 7 rows. So you see, we are getting 7 rows, right? If I say top 40%, it will pick top 4 rows. So this is the use of percent keyword when you are using the top keyword, right? So we have understood how we can use top keyword with our select statement. One more thing I want to mention in this video is the use of distinct keyword. Okay, so let's select star everything again. So I'm getting all this data. And let's select the job title. I want to see all the job titles. So I am selecting all the job titles. But if you see here, the job titles, software engineer, software engineer, software engineer, it is coming 3 times. Similarly, if you see the HR executive is coming twice. So basically we have duplicate values in this result set. With use of distinct keyword, you can avoid these duplicate values and only select, as the name suggests, distinct values from this data set. Or we can say the unique values from this data set. So I can say distinct here. Distinct is one more keyword in SQL Server. So when I say select distinct job titles, right? If you look at this data set, we don't have any duplicate entries here. All are unique values. Okay. Let's select star from employees again. Okay. Let's say I want to see a unique combination of job title and city. So what I can say distinct job title, comma, city. Let's execute this. And this time you can see I'm getting all the records. Titles are unique, but if you see the cities are getting duplicated. Meaning when we are saying distinct job title and city, it will basically pick the unique combination of these two values, right? So accountant Boston, financial analyst in Boston, right? So it is picking the unique combination of city and the job title, right? I can say the first name here also. If I say first name also, it will pick the unique combination of job title, city, and the first name. Let's execute this. Now we are getting all our data because there is no duplicate for these 3 combination, right? Okay guys, so this is how you can use distinct keyword in SQL Server. In this video, let's understand how we can filter our data using where clause in SQL Server. If you notice here, we have this employees table and it is having 10 records. If I do select star from employees, we will get all the records. But let's say you want to filter this data. Let's say you want to data of the employees who are in city New York. How you can do that? It's very simple. You can simply add a where clause after your select query. You can write where city, you can specify the column name on which you want to put the filter, and then you can specify the condition that you want to check. I want to check if the city is New York, then only select that particular row. So I will specify New York here. What I'm saying, select star from employees where city is equal to New York. Let me execute this, and you see I'm getting all the records where the city is equal to New York. So this is the equal to operator. We can use this to specify the condition where you want to check the equality of the value. Similarly, equal to, we have not equal to also. I can say not equal to New York like this exclamation mark and then the equal to sign. This is not equal to operator. If I execute this, I will get all the data where the city is not equal to New York. We can do the same thing with a different operator using the angular brackets. I can specify like this, the angular brackets, and if I execute this, this will also give the same result. So for not equal to, you can either use that earlier one like this symbol, or you can use this particular one. Both will work just fine. So we have seen equal to operator, we have seen not equal to operator. Now let's see how we can filter the data using the greater than or less than operators. Let's say I want to find the employees where the salary is greater than 58,000. Let's do that. So I will put salary here this time, and I will say salary is greater than 58,000. If you notice here, earlier I was using single quotes. I was specifying the string values in single quotes, but for numeric values, there is no need to specify the single quotes. You can directly put the values like this. I am saying salary greater than 58,000. Okay, let me change the condition. Let me say salary is greater than 75,000. Let's execute. This time I'm only getting 5 records. So this is greater than operator. Similarly, we have less than operator also. If I want to get the employees where salary is less than 57,000, I can use this less than also. So this time I'm getting all the employees where salary is less than 75,000. We have less than equal to operator also. So it will select the employees where the salary is either less than or equal to 75,000. We don't have any such case, I think. So let's use 58,000 here. And if I execute this, I'm getting 58,000 because there is no one who is having less than, but there is only one employee where the salary is equal to 58,000. So we are selecting that particular. Similarly, we have greater than equal to also. If I do this and let me change the salary to 75,000, so it will select all the employees where the salary is greater than 75,000, including the employee where the salary is 75,000. So this is greater than and equal to operator. Now let's see how we can combine the conditions. Previously we were applying only one single condition in our where clause, but we can combine our condition also. Let's say you want to see the employees where the city is New York and the job title is software engineer. You can combine the conditions using the AND operator. Let me show you how. So you can specify the where clause where city is equal to, I can say New York. And after this, I can specify one more condition and job title is equal to software engineer, right? So I'm using this AND operator to combine these two conditions. So I will only get the records where these two conditions are matching. Let me execute this. So there are 3 records where the city is New York and the job title is software engineer. I can use the OR condition also. So what will happen with the OR condition? It will pick all the records where the city is either New York or the job title is software engineer. So we can use OR operator to combine these two conditions, but this time either one of these condition is true, that time we will pick the record. Let me execute this. You can see we still have 3 records. Now let's change this condition so that we can understand the OR condition in a proper way. Let me change the first name here and let me say Emily here. So it will pick the record where either the city is New York or the first name is equal to Emily. Let me execute this. You see, I'm getting all the records where the city is New York, and I'm also getting the record where the first name is Emily. So this is the OR operator. Let's see all the data again. Now let's say the requirement is I want to get all the employees who are working in New York, Boston, or Chicago. So the one way to do this is I can specify where city is equal to New York, or the city is equal to Chicago, or the city is equal to Boston. So I can specify 3 equal to conditions and I can use the OR operator. That will also work fine. But in SQL Server, we have something like in keyword. So I can say where city in, and I can specify all the values that I want to check in the bracket. So I want to check either the city is New York or Chicago or Boston. So this time I will get all the records where the city is in these 3. If there is city which is not belonging to these 3 values, we will not return that particular record. Let me execute this. See, I'm getting all the records where the city is either New York, Chicago, or Boston. Right. Similar to in, we have not in also. So I can specify the not keyword and I can say not in, and I can execute this. This time I'm getting all the records where the city is neither New York, neither Chicago, nor the Boston. So out of these three, whatever cities are available, that we are picking up and showing here. Let's see the data again. Now let's look at this join date here. Let's say I want to find the employees who has joined between 2018 and 2020. So I want to specify a range here. When you want to specify a range in your condition, you can use between keyword. Let me show you how that can be used. So I can say join date, I can say the between keyword, and I can specify from which I want to check. Let's say I want to check from 2018, between 2018, and I can specify the date of 2020. I can say December 31st. So I am picking all the records where the joining date is between these two dates. Let's execute this. And you see, I'm getting all the records where the joining date is between these two values. So this is how you can use the between keyword when you want to specify the range. One more thing I want to mention here. Currently, we don't have any null records in this table, but if you want to check the null conditions, there is something like is null operator. So you can specify is null. So what it will do, it will check for the records where the join date is null. When you want to check the null condition, it is recommended, or it is the correct way to use it, is null. You should not check it with join date is equal to null, right? So you should use join date is null. Currently we don't have any record where the join date is null, so I will not get anything. But let me update my table. So I'm updating the employee ID 1 with join date as null here. Let's see the data again. So I have this join date null here. So what I'm saying, select all the records where the join date is null. So we have only one record, so we should get only this record in our result set. As expected, we are getting that particular row. Similar to is null, we have is not null. So this will only pick the records where the join date is not null. Let's execute this also. And I'm getting 9 records. It has skipped the employee ID 1 because there the join date is null. In this video, let's understand how we can use wildcards in SQL Server. What I want, right? I want to get the employees where the employee name is starting with D. So I can specify this in a where clause. So I can say where first name, and I can use the like operator. So like operator can be used in SQL Server, and this can take a pattern. I can specify the employee name should start with D, and I can specify a percentage. So what is the meaning of this? It means the employee name should start with D and it can have anything after that. Let me execute this. I'm getting two records where the first name is starting with D, and after this it can have anything. Let's say I want to get the employees where the employee name starts with DAV. If you see, there is only one employee where the first name starting with DAV, that is David, employee ID 5. If I execute this, I will get that particular record. So this percentage sign can be used to specify wildcard characters. Let's see all the data again. I can say it can start with anything, but the name should end with Y. I want to get these kind of employees. Let me execute. There is only one record where the name ends with Y. So that's why I'm getting only one record. So you can specify percentage in front also. What else you can do with the like operator? You can specify 2%. Let's say I want to get the employees where there is a O in their name. Okay. So what I'm saying, there should be an O character in their first name. It can be at the first position, in the middle, or at the end. Let me execute this. And you see, I'm getting 3 records because all these 3 employees are having O in their first name. So this is how you can specify a pattern and search the employees using the like keyword. And just like keyword, we have not like also. So this will basically give the negative results. So if I execute this, so it will give me all the records where there is no O present in their first name. Right, so there is one more wildcard, that is underscore. So we can use underscore also. Okay, let me specify a condition here, like I'm getting the 8 records. Okay, so what I want to say here, right, the name should have a I at the second place. Okay, so what I want to say, there should be exactly one character in front of I. So what I said, underscore I. Okay, and after this I can specify percentage, meaning it can have anything after I, right? There should be one character before I, and after this it can have any characters. Let me execute this. You see, I'm getting all the records where the I is at the second place. There is exactly one character in front of I. So you can specify this underscore and filter the data like this also. And you can use multiple ones also, like you can say there is one character after I, and after that there is an H. So if you see what I'm saying, there is one character in front of I, there is one character after the I character, and there is H after that particular character. Okay, and then there is a percentage, meaning all there can be any character after that. Okay, if I execute this, if you notice in this record set, I have this particular pattern matching with the employee ID 3. Correct, let's execute this particular query, and I am getting that particular record. So this is how you can use underscore while specifying the like keyword. Now again, see the data. Let's say you want to find the employees where the first name is starting with either J or S. How you can specify that? For that, you can use square brackets. Within the square bracket, you can specify the name can start with J or it can start with M. And after this, it can have any character. I am specifying J and M within the square brackets. Let's execute this. So I'm getting all the employees where the first name is starting with either J or it is starting with M. Similar to this, we can have a negative operator also. So I can specify a head symbol. Okay, so I can specify this hat symbol here. It means it will pick all the records where the name is not starting with J and is not starting with M also. Basically the reverse of the condition that we have applied earlier. So if I execute this, if you see, there is no employee where the name is starting with J or M. So this is how you can use these square brackets with the hat symbol to specify your conditions. That's it for this video. In this video, we have understood how we can use different type of wild characters with the like keyword. In this video, let's understand how we can sort our data using order by clause. Till now, we have seen how we can select our data. Basically, select will control how many columns you will see after the execution of the query. Right? So I can specify the column names here, like first name, last name, and based on this, it will select the columns. Okay. So select will control how many columns you will see. And we have seen how we can filter our data with the where clause. With the where clause, I can say first name equal to John. So if I execute this, I will get one row. So basically, select is controlling what are the columns I will select, and where clause is telling me what are the rows I will be selecting. So till now we have learned about select and where clauses. Let's remove everything and see all the data. Let's say I want to see this data in some particular order, right? Currently, if you see by default, it will order it on my primary key, which is employee ID. You can see it is 1, 2, 3, 4, 5. So basically the employee ID is in incremental order. But if you see other thing like department is randomly here. But if you want to sort your data with some different column, you can do that also by using the order by clause. Okay, so you can use order by, and then you can specify the column. Let me say department. If I say department here and execute this, you notice first I'm getting admin department, then finance, then HR, and finally IT. So basically now department is sorted in the ascending order from A to Z. Okay, and if I say DESC here, which stands for descending, so basically this order by will be applied in the reverse order. If I execute this, you see first I'm getting the IT, then HR, then finance, and finally admin. So we can control in which order I want to sort my data. Along with that, you can combine other columns in the order by. Let me show you how. So we are getting this data. Let's say I want to sort by salary also. I want to see which employee is earning most in the IT department, which employee is earning most in the finance department. So for that, you can say order by department comma salary. Okay. Once you do this, let's see what will happen. If I execute here, you will notice now the records are sorted by department, and within the department you will notice they are also sorted by the salary from the lowest to the highest, right? If you see 75,000, then 90,000, and so on. Similarly for the HR, the lowest salary is coming at the top because by default the ascending order will be picked. And if I say descending here, then the salary will be sorted in the descending order, meaning the highest salary will be at the top. Now I can see in the IT department, this particular employee ID 7 is earning the most. So you can specify multiple columns also and specify in which direction you want to sort, either descending or ascending. So the ascending is the default order, but you can specify ASC also, which stands for ascending, right? If you execute this, you will get the same result. We are ordering the data on the department column in the ascending order. Okay guys, that's it for this video. In the next video, we will see how we can use group by and having clause in SQL Server. In this video, let's understand the purpose of group by and having clause in SQL Server. Okay, so this is one orders table. Here we have order ID, customer ID, product category, amount, and the order date. And what I want, right? I want something like this. I want to see each product category and the total sales. Because here, if you see, the sale amount is distributed among the order IDs. But I want to see this kind of result set where I can see clothing has how much sale, electronics this much sale, and the grocery will have this much sale. So let's see how we can write this kind of query in SQL Server. So I have already created this orders table and I have this required data for this demo. I want to see each product category and I want to see the total amount. So let's do select product category, comma, sum of order amount. So we want product category and the sum of their amount. From which table I want? I want it from the orders table. And guys, we have not understood what is sum function. Basically, this is an aggregate function that will sum up the data, right? So if I want the sum of order amount, I can use sum and then pass the order amount. Then it will give me the sum. We will understand this sum function in detail in our later videos. But here, let's see how we can use group by. Okay, so I can say group by product category. If I say group by product category, let's see the result. If you notice, now the data is aggregated. I mean, I can see the clothing, this much sales, electronics, 57,000, grocery, 3,600. So I am able to get data which I was expecting. If you see here in these slides, this is what we were expecting. I want the product categories and the sales among each category, right? And if you see, we have this total sales written here, but if you notice here, we see no column name here. That is because we have not provided any alias for this particular column. And we can provide an alias by using the as keyword. I can say as total sales. Let's execute this query again. Now I can see total sales here. So this is how you can provide an alias. There are multiple ways. You don't need as also. You can remove this and then also you will get the same result. You don't need the single quotes also. You can remove that also and if you execute this, you will get the same result. Okay, so this is how you can provide an alias to a column which doesn't have a column name. Let's say I only want to see the data where the sales is greater than 3500. For that, we can use a having clause. With group by, you can append a having clause with the having keyword. Here you can say having sum of order amount greater than 3500. If I execute this, I will get only the records where the sum of the total sales is greater than 3500. Let's remove this and see the data again. Having can be used with the aggregate functions. Also, it can be used with the normal columns also. So I can say where product category equal to clothing. Like if I want to see for the clothing, I can see that also. If I execute this, I will get for the clothing. So you can use having also here, and you can do the same thing with the where clause also. For this, I can put it here and let's change to where. And if I execute this, I will get the same result. But the difference between where and having is where cannot be used with the aggregate functions. If I try to use an aggregate function like sum with a where clause, let me see here, order sum amount is greater than 3500. Let's see if this will work. You see, I'm getting an error because an aggregate function may not appear in where clause. For that, we have to use a having clause. So guys, this is the difference between a where and a having clause. And you can use multiple columns also within the group by clause. Like this is the data I have, right? And if I do group by on product category, I can get product category and their individual sum. Electronics, this is the total sales, right? Okay. If you see the data again, we have customer ID column also. Let's say I want to aggregate along with product category and the customer ID, meaning I can say electronics is having sales of 57,000. I also want to see which customer is contributing to this particular sales. Let's see how we can do that also. In the group by, I can specify customer ID, and I can specify the customer ID in my select clause also. If I execute this, let me do an order by also so that we can see this picture clearly. Order by product category. If I execute this now, customer ID 1 is spending 20,000 on electronics, customer ID 2 is spending 22,000 in electronics, and customer ID 4 is spending 15,000. So this total comes up to the 57,000. So that's what we were saying when we were executing without the customer ID in the group by. So we can break down this sum by adding the more columns in the group by. And guys, one more thing I want to mention here, in the select query, you can only mention the columns which are present in the group by. You cannot mention customer ID if that is not present in the group by clause. If you remove this customer ID from here and try to execute this, you will get the error because it will say customer ID is invalid because this is not part of our aggregate function and not part of our group by. So the columns that we are specifying in our select query, that should be present in our group by clause. That's it for this video guys. In the next video, we will start our discussion on SQL Server joins and we will see how we can fetch data from multiple tables. Hello and welcome. In this video, let's understand what are joins in SQL Server. Joins are basically used to get data from multiple tables. When you have two tables and you want to combine data of both the tables, you can use joins and get the data. There are multiple type of joins in SQL Server. If you look at this picture, we have inner join. Inner join will basically give the matching records from both the tables. We have table 1 and we have a table 2. And if we perform inner join, it will basically give the matching rows, meaning the data which are present in both the tables. Let's understand this with an example. Let's look at these two tables. I have employees table and I have departments table. We have department ID common in both of these tables, and using this column we can join these two tables. Let's say the requirement is I want to see each employees and the name of their particular department. So for this, what we can do, we can write a join between these two tables. So I want employee name and the department name of that particular employee. So what I need to select, I need to select the employee name and I want to select the department name. From which table I will be selecting it. So the employee name will be coming from employees table. So let's write that from employees. Now I need to make use of my second table, that is departments table. So I need to join this two table. I can do that with inner join. I can type inner join and then I can specify the second table, which is my departments. So using this keyword inner join, we can join two tables. And after writing this inner join, we need to specify the condition. Basically, we need to tell how these two tables should be joined. As we have discussed earlier, both of these tables are having department ID as a common column. So we can join these two tables using this particular column. So let's see how we can do that. To specify the condition on which we are joining it, we need to specify on keyword. So we are doing this inner join on this condition. I want to use the department ID from the employees table. So I can specify that with the table name dot department ID. Okay, so I can select this column from this table. Similarly, I will say this department ID is equal to department ID from the departments table. So I can say departments dot department ID, right? So using this, we can join these two tables. If I execute this now, you see I am getting only the four records and I am able to fetch the employee name and their particular department, right? But if you see the initial data, let's see the employees. There were five employees, but if you look at this carefully, one employee is not having any department, right? So the employee ID 5, that is David, is not assigned with any department. That's why when we execute this query, we only get four records and the employee ID 5, David, is not available in this. That is because if you see this picture, we are only getting the matching records. The department IDs which are common in both the tables, in the employee table and in the departments table, only those data will be fetched. Right. So let's go back to SSMS and we can see this. When we are joining this, the employee ID 5 is not coming, only the matching records are coming. So this is our first join. This is the inner join. Let's see the other type of joins that are available. Let's go back to slides. So the second type of join is the left join. In left join, if you see, we are selecting all the data from table 1 and also we are selecting the matching data, the data that is common in table 1 and table 2. But we are not selecting the unmatched record of table 2. For that, we can use the left join. So if I change my condition here from inner join to, let's copy paste this one more time so that we have the earlier query also for reference. So let me rewrite this query and this time I will change it to the left join. On the left hand side, which table I have? I have employees table. By doing left join, we are making sure we are getting all the records from our employees table. Along with that, we will get the matching records from our departments table. Let's execute this. You see, I am getting all the records, all five records from the employees table, and we are getting the David also, where the department is not available. Simply the SQL server will put a null there because we are not able to find a department for David, right? So this is our left join. Similar to left join, we have the right join also. As the name suggests, in left we got all the data from the left table. In the right join, we will get all the data from the right hand side table, that is nothing but departments table. Let's see the data again in these two tables. If you notice, we have this department ID 4 that is not available in our employees table. No employee is having department ID 4, right? So when we were executing inner join, we were not getting the IT department, that is department ID 4. When we did left join, that time also we were not getting the department ID 4, right? Because that was not available in the employees table. But when we do the right join, let's copy paste this query again. And this time let's change the left to right and execute the same thing again. Okay, you see, I'm getting all the records from my department table, but I'm only getting the records from the employees table where we have a department. Only the matching records are coming from the employees table. That's why the David, who is not assigned with the department, that is not coming in this result set. So this is our right join. We can confirm this again here. On the left hand side, we have this employee David who is having department ID as null. So we have seen how we can use inner join, left join, and right join. And the fourth picture you will be seeing here is for the full join. When you want all the data from table 1 and table 2, irrespective of if the data is matching or not, you just want to get the data. You just want all the data from both of these tables. For that, you can do a full join. Let's see that also in action. Let me copy this query again and paste it, and let me do a full join. Okay, so you can use full join to do this. Let's execute this now. And we are getting all the records from our employees table. You see, we have this David also, and we are getting all the records from our department table also. And you see, we have this IT department, and we don't have any employee for that department. That's why we are seeing null here. Okay, so this is the purpose of full join when you want to get all the data from both these tables. Now I want to introduce you to the concept of alias. Okay, let's say when we were doing this inner join, right, we were getting the employee name and the department name. But let's say you want the department ID also. So let me put the department ID in my select clause. So I am saying employee name, department name, and the department ID. I'm already getting this red error line here. And the error says ambiguous column name department ID. And if I execute this query, you will notice the error ambiguous column name department ID. That is because department ID is present in employees and departments, but we are not sure from which table we want to select this department ID. That's why SQL Server is confused and not able to select this particular column. To make this column unambiguous, we can specify the table name and then we can say dot here. So we are selecting department ID and we are explicitly saying we want to select it from the employees table. If I execute this now, it will work and I will get the department ID here. Instead of specifying this complete table name, what you can do, you can make use of alias. Let me show you how. Let me copy this query and paste it again. And this time we can provide an alias instead of specifying this complete table name. I can say employees. Let me give an alias to this table name as E. For the departments, I will give D. Okay. Once that is done, no need to type the complete table name. You can just say E dot department ID and that will work. Similarly, you can use this alias on this particular condition. You can say E dot department ID is equal to D dot department ID. So you don't have to type the complete table name again. And if you execute this, you will get the same result set back. So this is how you can use alias when there is an ambiguous column name in two tables. And guys, one more thing I want to mention here, right? When we are joining two tables, the best practice is to make use of primary keys and foreign keys, because those keys are kind of unique, because the primary key will be unique in the table, and the foreign key is basically a primary key in some other table, so that will also be unique. So if I see my employees table, I have the primary key as my employee ID. We can see here the employee ID is my primary key, and similarly the department ID, right? So we have this department ID that is my foreign key. So in the employees table, I have the primary key as employee ID, and the foreign key is my department ID, right? And the departments table, I have the department ID as my primary key. So what we are doing when we are saying department ID is equal to department ID, this is foreign key. We are matching this foreign key with the primary key. So this is how you should be joining your tables. You should make use of the primary keys and the foreign keys, and based on that, you should be joining your data. It is not mandatory, but this is the best practice when you are joining two tables. That's it for this video, guys. In the next video, we will understand what are some advanced joins that you can perform in SQL Server. In this video, let's discuss the advanced joins that are available in SQL Server. So in the last video, we have seen what is left join. In the left join, we were able to get all the data from the left table, including the matching records, right? So we were getting this inner section also. We have also seen the inner join, where we were getting the matching records from both the tables, table A and table B. We have also seen the right join, where we were able to get all the data from the table B, including the matching data. And we have also performed a full join, that is also called as full outer join, where we were able to get all the data from table A and table B, including the matching data also. In this video, let's discuss other joins that are available in SQL Server. First one is the left join excluding inner join, meaning we will get all the data from the table A, but we will not get the matching records. We will only get the data which is exclusively present in the table A. So let's see how we can perform this type of join. So we have these two tables, employees table and the departments table. If you notice, we have David, department ID is null here. David is not having any department, right? So department ID 1, 2, 3 are present here in for these four employees, and these four are present here also, right? So when we were doing left join, inner join, and the right join, we were able to get the matching data. But this time I want to skip the matching data, and it is very simple. So we were doing this left join here, right? When I was doing the left join, I was getting this data. If I want the data which is only present in the left hand side table, for that I can specify a where condition here. Let's copy paste this query at the bottom so that we will have a reference. And I can specify a where clause here, where department ID is null. Okay, when you execute this particular query, you will get only the non-matching records. So the matching records are now gone. You are only getting the non-matching records, which is same as we were seeing in this picture. We are getting all the records from table A, but we are not getting the records which are matching. I mean, which are present in table B also. So we are only getting the exclusive data from the employees table. Okay, so this type of join can be useful when you want to get the employees who are not assigned with any department, right? So you can perform this left join and find the employees who are not having any department against them. Similarly, we have this right join excluding inner join. We will get the data from table B, but we will not get the matching data. And that is also very simple. We can copy this. So this is what we were doing earlier. We were doing the right join. Here, I can specify a condition where employee dot department ID is null. If I execute this, I will get IT department. Why IT department? Because IT department is the only department that is not having any employees in it. If you see the data again, you see we have this IT department 4 that is only present in the department table. It is not available in the employee table, right? So that's why if you see the picture again, we are getting the records which are exclusively present in the table B, right? So we are not getting the matching records also. Now let's see how we can perform a outer join excluding the inner join. So I want the unmatched record from table A, unmatched record from the table B, but I don't want the matched record from both the tables. For that, you can make use of full join. Let's copy this query. If you remember what we were getting in the full join, I was getting all the data, irrespective of if we have a matching record or not. So we can make use of this and we can say where employee dot department ID is null or employees dot employee ID is null, right? So if I execute this particular query, I will get these bottom two records, right? So let's execute this and I'm getting the employee where there is no department and I'm getting the department where there is no employee. So this is same as what we were seeing in this picture. We are getting the non-matching employees and non-matching departments. Okay guys, that's it for this video. In this video, we have seen what are some advanced join which are available in SQL Server. In the next video, we will discuss what is a self join. In this video, let's understand what is a self-join. Let's look at our employees table. We have employee ID here. We have manager ID here, right? So what we are saying here the employee ID 2, Ria, is having manager ID as 1. Manager ID 1 means employee ID 1, that is Amit. It means Amit is manager of Ria. So here there is a relationship between the table itself. If I want to get the employee name and their manager name, how we can do that? Let's write a self join for that. So self join will be very useful in these kind of scenarios. And guys, this is one of the most important interview question that you will be asked in your SQL Server interview. So let's understand what is self join. I will be writing a select and I will be selecting everything because currently I'm not sure which tables I will be having. So I'm just selecting everything here. Okay, so this is how we start. Let's move on. From which table I want to select the data? One table I know, that is employees. For sure, I want to use this table. Let's give this table as alias as E. Okay. And the requirement here is I also want to select the employees who are not having any manager. Okay. So for that, I can use a left join. Now I need to specify my second table. But surprisingly, there is no second table. There is only one table, that is employees. We need to make use of employee table to get the manager data also. So let's join the employees table with the employees table. That's why it is called as self join. So I am joining the employees table with the employees table and I am saying alias as M. What should be the condition to match these two tables? I will say on E dot manager ID. Okay, so I will consider this table as my employees data, this table as my manager's data. Okay, so I'm saying E dot manager ID is equal to M dot employee ID. So what I'm saying, the manager ID that is specified here is the employee ID in this particular table. If I execute this as it is, I will get all the records. And if you see here, I have this employee name and I am getting this employee name here also. But you can see this time I am having the employee name as Amit, which is correct because Amit is manager of Ria. So let's specify employee name here. So I will say e dot employee name and m dot employee name. Okay. If I execute this now, I am getting Amit is manager of Priya, John is manager of Sarah. But this is not very convenient because both of those columns are saying employee name. So we can use an alias here and I can say manager name. Let's execute this query again. And this time we are getting the expected result. We are getting the manager name and the employee name who are working under them, right? So this is how you can use self join and join the same table with itself and get the data which you want. In this video, let's understand what is a cross join in SQL Server. So I have these two tables. I have team A and team B. They are only having one column, that is player name. Okay. So team A is having 10 players. Team B is also having 10 players. Now, the requirement is you want to set up games between these two teams, and each player from team A will compete with each player from team B. You can make use of cross join. Let me show you how. You can say select, and I will say star from team A. Let me give an alias here as A. Cross join team B. I will give an alias as B here. Now you can select your columns. I will select A dot player name and B dot player name. If you have noticed, we have not specified any condition here because this works without any condition. I want to match each record from table A with each records from table B without any condition. If I execute this, so if you see this result set, Henry is matched with all the players from team A, right? Then the second player from this team is matched with every player from the other team. Similarly for this third player and so on. So each record from table A is matched with each record from table B. Okay. And if you see the total number of records we are getting is 100, and that is because in team A we have 10 players, in team B we have 10 players. When you do a cross join, that will basically multiply the records. 10 into 10, we get 100 records in the cross join result set. So this is how you can use cross join in SQL Server. In this video, let's see how we can join more than two tables in SQL Server. Till now, what we have seen, we were joining employees table with departments table, and each type of joins, we were using two tables and joining them with some condition. Let's say we have one more table. We have employee projects and we have projects table also. Okay, so we have these four tables. Now, what I want to do, right? I want to see the employee name and their project name. I mean, to which project they are assigned. To get this kind of data, I want to join employees table with the employees projects table, and then I want to get the project name from the projects table. So it will require three tables in the join statement. But let's see how that can be done. So I will start with select star. Okay, and I will specify the first table obviously will be the employees. So I will put an employees table here and I will say E as an alias for this table. I will do an inner join here and I will join it with the employee projects and I will call it EP as my alias, and I will specify one condition here on which condition I'm joining this. E dot employee ID is equal to EP dot employee ID, right? But this will not give me project name because project name is present in projects table. If you notice, we have the project name here. Then we need to join this table also. Inner join projects, I will call it P. And what should be the condition here? The condition should be ep dot project id is equal to p dot project name, right? So we are joining three tables this time. We are joining employees table with employees projects, and we are joining projects table with the employee projects table, right? With this particular condition. Actually, this is the wrong condition. P dot project name, this is incorrect. Let's change it to p dot project id because the project id is what we have common between these two tables. Once that is done, after that it is very simple. I can just select e dot employee name and p dot project name. So this will give me the employee name and their project name. Let's execute this. You see, so this particular employee Amit is assigned with website redesign, and he is also assigned with mobile app. Ria is working on mobile app project and John is working on HR automation. So this is how you can join more than two tables in SQL Server. Hello and welcome. In this video, let's talk about is null and coalesce function in SQL Server. So I have this table employees and it has many columns. But if you look here, there are many nulls value that are present in this table. Let's say I want to see base salary column and I don't want to see the null here. I want to see 0 if the value present is null. Okay, so if I do a select star, let's say employee name, base salary. Okay, so I'm selecting two columns, name and base salary. If I select this, you can see I have two null values here. I want to replace these null values with 0. What I can do, I can use is null function. So I can say is null, and is null will basically take two parameter. First parameter will be checked. If the first parameter is null, then the value will be replaced with the second parameter. I can specify 0 here. If I execute this now, you notice I don't see any null here and I can see 0.00 is added here, right? So the value of base salary null is replaced with 0. And why we are saying 0.00 and not 0? That is because the data type of base salary is decimal. It is not integer. That's why we are saying 0.00. So the data 0 is converted to decimal. Okay, so this is the behavior of is null. Is null will take the data type of the first parameter and it will change the second parameter to that particular type. Let's say I want to change it to something, let's say ABC. What will happen in this case? Because base salary is of decimal data type and ABC is a string, so we want to be able to convert ABC to decimal data type. And if I execute this, I can see the error converting data type varchar to numeric. So we are not able to convert this particular value to a numeric, correct? So this is the behavior of is null. Now let's see the coalesce function also. So let's see all the data from our table, select star from employees. So what I want to do, right? I want to find a main phone number for that employee. I want to return phone number if phone number is present. If phone number is null, then I want to return the alternate phone number. If alternate phone number is also null, then I want to return the emergency phone number. Okay. So one thing like is null can take only two parameter, but to handle these kind of situations where we can have null in multiple places, we can use coalesce function. Let me show you how. Let's again select name of the employee and let's say coalesce, and coalesce can take any number of parameter. First parameter I will say phone number. Second parameter I will give as alternate phone number. alternate phone. Third one is emergency phone. If all of these three values are null, right? We have some records where all these three values are null. I want to say no number available. Let's execute this query. Let's see the complete data set so that we can compare what has been done by coalesce function. So let's do select star from employees. Okay, let's execute these two queries. Okay, so what is done here? For the first employee Alice, I can see we have returned the phone number, right? For the second employee, we have returned the alternate phone. That is because the phone was having the null entry. So we have skipped that and we captured alternate phone. If you see the third employee, Charlie, here we have skipped phone. Then we checked alternate phone, that was also null. But we finally found the emergency phone. Then we return emergency phone here, right? And David and Emma are not having any of these three values. So we have returned no number available. So this is the main difference between is null and coalesce. Is null will basically take only two parameter. You cannot specify any more parameter in is null function, but coalesce can take any number of parameters. Okay. Now let's see the behavior with the data type with the coalesce function. In the base type, we saw whatever data type specified for the first parameter that will be picked, and the second parameter will be casted to that particular data type. Let's see one more example with is null. So I will say select is null and I will say convert varchar 5 and I will say null here. Okay, and the second parameter I will say hello world. Okay, so what I'm doing, I'm using is null function here, and the first parameter I'm specifying null, but the data type I'm specifying is varchar 5, and the second parameter is hello world. If I execute this, you see only hello is getting printed. If I see varchar 2 here and execute this now, only the HE is getting printed. That is because, as we discussed earlier, data type will be picked from the first parameter and the second parameter will be casted or the converted to that particular data type. So we have converted hello world to varchar 2. That's why only two characters are getting printed here. Okay, let's see the same thing with coalesce function. Let's copy paste this and instead of using is null, I will use the coalesce. I will change it here and let's execute this now. And I'm getting the complete hello world. So what coalesce will do, right? It will look for the bigger data type. So the first parameter was having varchar 2 and second was having varchar and whatever the size of this particular string. So coalesce has looked for the largest data type, that is here, the second parameter, and that will be used as the return data type. That's why there is no trimming of this string when we have used this coalesce function, right? So you can see the result of both of these functions. Isnull has trimmed the string, but coalesce was able to perform this operation without any issue. Function in SQL Server. In this video, let's talk about union and union all operators. I have created these two tables, sales 2024, sales 2025. And if I see the data here, I have this data in these two tables. Now let's say the requirement is I want to combine the data of this table and this table. So what I can do, I can use union in this case. So I can say select star from sales 24 and I can say union. So what I'm saying select star from sales 2024 union select star from sales 2025. Let's execute this. And you see we are getting the rows combined. We are not getting two separate result set. The result sets are merged and we are getting one single result set. So this is the purpose of a union. When you want to combine result sets from two different queries into one, you can use union. But if you notice here, right, let me remove union once. And if I execute here, we were having 6 rows, right? But when we performed union, you notice what happened. So when we are doing union, we are only getting 5 records. Why is that? That is because if you check your data, we have this particular record here, order ID 3, customer name Charlie. It is available in the second result set also, order 3 Charlie. That's why when SQL Server has performed the union, it has removed this duplicate record. That's why we are seeing this record only once, right? Order ID 3 Charlie is present only once. That is the behavior of union. But in case of union all, you will get all the records, no matter if they are duplicate or not. So I am using union all this time, and let me execute this. You see, I'm getting these duplicate records also. So this is one of the difference between union and union all. Union will not give you duplicate data, and union all will give you the duplicate data. Let's do one thing. Let's take this first and then do a union, and let's copy the second query. Okay. Now let's execute this. You see, I'm getting this data in ordered manner. I'm not getting the data of 2025 above and 2024 below, right? Because if you see 2025 is having first record as Charlie, David, Emma. But when we perform the union, even though we have the table 2025 above, but union will remove the duplicates and it will order your records also, right? So it will sort the data when you will get the result. But let's perform union all here. If I perform union all here, you notice the data is not sorted. We are getting the records as it is from 2025 table, sales 2025 table, and then we are getting the data from the sales 2024 table, right? So this is the second difference. Union will actually sort the data, but union all will not sort your data. That's why union all is very performance friendly, whereas union has to do a lot of tasks to complete its execution, and that's why it is not recommended to use union when you are dealing with a lot of data. Let's go back to slides. Okay, so here on the slides also you can see the differences. Union will remove the duplicates, whereas union all will not remove it, and union has to perform distinct sort to remove the duplicates. So the union has to perform the sort in order to remove the duplicates, right? So this is why union all is faster, whereas union will be slower operation. Okay, and with respect to the order by clause, you can perform order by on the second query. Let me show you what I mean by this. If you see this query, union all, let's, or we can say union also. So I can perform order by at the second query. I mean, at the end, I can perform the order by, right? I can perform the order by here, right? If I execute this, I'm getting the order sorted by the customer name. Let me say descending here. So I'm getting the data that is ordered by customer name, but in descending order. But I cannot apply this order by on the first query, right? If I try to do this, I am getting an error, invalid syntax near union, and this makes sense also. So what is happening, right? SQL Server is first performing the union, and then only it can perform the order by, because there is no point in doing the order by on the first query, because we are going to append more data on this. That's why it is not allowed to perform order by on the first query. Once both the queries are executed, then only we can perform the order by. And guys, when you're performing union and union all, you need to make sure the columns are matching. The columns which are specified in the first select statement should match with the second select statement. What I mean by this, let's say I am selecting order ID here,
and customer name. Okay, let me do this for the second query also. When I'm executing this, it is working fine. But what will happen if I change the order of these columns? If I say customer name first, and let's say I'm saying order ID after this, if I execute this now, what will happen? Because customer name is string, so it cannot be merged with the column order ID, right? If I execute this, let's see the error. We are not able to convert Alice to data type integer. So what is happening here, right? If you see the data, we have Alice here, the customer Alice, and but here we have the order ID. So SQL Server is trying to convert this Alice to integer. That is not possible. That's why we are getting this particular error. So both the select query should have the same type of columns. So column should be matching as well as the number of columns should also match. If I remove a column here, right? Let's put the customer name at the second position. Okay, so what I'm doing, I'm selecting only order ID from my first query and I'm selecting two columns from my second query. This is also not allowed. If you run this, you will get this error. The all queries combined using union must have equal number of expressions in the target list. So the target list means the select list should have equal number of columns. Let's go back to slides again. And now let's discuss the difference between a union and a join. Union combines the result set of two or more select queries into a single result set. That is what we have seen. We are able to combine sales 2024 table with sales 2025 table, which includes all rows from the queries in the union. Whereas join retrieves data from two or more tables based on logical relationships between the tables. So joins will make use of relationships, meaning it will make use of primary keys and foreign key generally, and based on that it will retrieve the data. In short, we can say union combines rows from two or more tables, whereas join combines columns from two or more tables. And finally, we have a not for union and union all to work. The number, the data types, and the order of the columns in the select statement must be same, else we will get the compilation error that we have seen in our SSMS. Hello and welcome. In this video, let's understand what is a stored procedure. A stored procedure is basically a pre-written SQL program that is stored inside the database that can be executed whenever needed. If you have some piece of SQL that you want to execute frequently, what you can do, you can create a stored procedure for that and you can call it any number of times. What it allows is it allows us to group multiple SQL statements like select, insert, update, delete into a reusable piece of code. Okay, so here is an example. Like let's say you want to get the employees. For that, you need to write select star from employees. So instead of writing this query select star from employees again and again, what you can do, you can create this procedure at once. And after that, after the procedure is created, you can just invoke this procedure get employees, and that will invoke all the code that is written inside this procedure. Now let's go to SQL Server Management Studio and try to create one simple stored procedure. So I have connected to my database and I have this particular table here, employees, and this has some 5 rows. Now let's see how we can write a stored procedure to get this data. Writing a stored procedure is very simple. We need to start with keywords create procedure. After that, we need to specify name of the procedure. I will name it get all employees. After that, you need to say as, then you need to say begin and end it here. So this is how you will create a stored procedure. So we need to give create, then procedure, then the name of the procedure, then as begin, and then whatever you want to execute with that procedure. Let's say I want to execute this query only. So I will copy this and put it here, and that's it, right? Let's remove this query.
Right. So this is how you will create a stored procedure. Let's execute this. Right. So the procedure has been created, and if you want to see the procedures, you can go to programmability folder here. Inside this, you will find stored procedures, and you can see your procedure is right here, get all employees. So this is how you can create stored procedures in SQL Server. Now, let's see the advantages of stored procedures. First of all, reusability. We can write the SQL logic once and then we can use it multiple times. We don't have to write SQL logic again and again. Better performance. Stored procedures are compiled and optimized by SQL Server so that whenever you will execute the stored procedure, that will be quicker because SQL Server don't have to compile and optimize the SQL code that you are writing. So procedures can provide you better performance. Security. Users can execute stored procedure without direct access to the tables. So I don't have to provide access to the tables. Instead of that, I can directly provide my stored procedure and users can execute that procedures. Because of that, user won't be able to know what is the tables involved in this procedure. Fourth advantage is reduced traffic network. That is because like stored procedure can have multiple queries, right? So instead of executing those queries one by one, we can just invoke the procedures and all the queries will be executed at once. So no need to go to database again and again and execute the queries. Easier maintenance because the stored procedure will have all the code at one place. It will be easy to update and maintain that piece of code. Okay, so how to create a stored procedure? We have already seen we need to use the create procedure statement, and this is how you can create a simple procedure. Okay, and how to execute the stored procedure? You need to use this exec or execute keyword to execute the procedure. So let's try this also. So to execute this procedure, I can say exec and then I can give the name of the procedure. I can select this and click on execute. This will execute the piece of code which is present inside this procedure. So I can execute this multiple times. I don't have to write this select start from employees again and again. Okay. So let's say there are 5 select statement, right? So instead of like executing all these 5 select statements again and again, so I can put those 5 statements in the procedure and execute them at once. So let's modify this procedure. I can modify it by using create or alter. So I can say create or alter, or I can just say alter this. So this will alter the procedure. So I can execute this. So the procedure has been modified. And now if I execute my procedure, I will get the result set 5 times, right? Because I was writing 5 select queries in this. So you are from employees. Let's see the data. I have this data here. Let's say I want to create a procedure. Let's say I will create procedure again and I will name it get all employees by name. So what I will do, I will take an input parameter here, and to take an input parameter, it is very straightforward. You can put these brackets here, and then you can define the input parameter that you want to accept from the user. So let's say I want to accept the name. So I can say name here, and then I need to specify the data type of this variable. So that would be a string. So I will define varchar, let's say 10 here. Okay, so this is one parameter that this procedure will accept when running. Okay, and I can modify my query here. I can say select start from employees where name equal to the variable that I will be receiving here. Let's put it here, right? So this is my procedure now. If I create this procedure and if I try to execute this procedure now, get all employee by name and execute this, you will notice I will get one error because now this procedure accepts one parameter, that is at the rate name, which we have not supplied. So let's supply that name also. Let's say I will supply Alice. Let's execute this again. See, I'm getting the employee whose name is Alice. Right, so we can see this in this example also. We can create a procedure where the department is the input and we can get the employees based on the department as well. Right, so the example execution could be get employees by department and we can pass the department name here. Stored procedure with insert, update, and delete. Stored procedure can also perform data modification operations, right? So what we can do, like we can create a stored procedure where I will be creating an add employee procedure that will take three parameters like the employee ID, name, and the department. And based on that, it will insert the data into the employees table. So I am finding the insert into employees, and I am like passing these parameters also here, ID, name, and department, right? So we can write updates also. We can update the table within the procedure. We can write delete statements. So these operations can also be performed inside the stored procedures. Okay, now let's see how we can alter and delete stored procedure. Altering the stored procedure, we have already seen. We can use the alter keyword, or we can use create or alter also. Like if we go to SSMS, like I'm creating this here. So if I want to modify this, I can either say alter, or I can say create or alter. So what this will do, this will either create this procedure if it is not available, but if this procedure is already available, it will alter the procedure. Okay, so we can either use create or alter, or we can just use alter to alter a stored procedure. Now let's see how we can delete a stored procedure. So we can delete a stored procedure by using the drop keyword. So I can say drop procedure and then the procedure name. So if I want to delete this particular procedure, so I can say drop procedure and then the procedure name is get employees by name. If I execute this, and if I execute and if I refresh my stored procedures folder, you can see I don't have this procedure here. Let's delete this particular procedure also, get all employees. So I can delete get all employee also by executing drop procedure get employee. Let's execute this, and this has been deleted also. If I refresh the stored procedures folder, refresh, now there is no data in this. So stored procedures are basically used widely in the real-time applications. Like you have some e-commerce application and you want to get the orders of a particular customer, you can create a procedure with the name get customer orders and take the customer ID as the input and fetch all the orders based on that. You can create a procedure with the name like create order that will insert new record in the orders table. You can write update employee salary to update the salary information of a employee. You can write generate monthly report, like if you want to generate a report, and for that you can write your SQL logic inside a stored procedure and create a procedure with this particular name or any friendly name that you want and use it wherever you want to execute that piece of code. Logging the user, like you can accept username and passwords and then validate if the user is a valid one or not. So in the most enterprise application, most databases operations are performed using stored procedure. So this is the must know feature if you want to become a database developer. In the next video, we will continue our discussion on stored procedure and we can see what are the different type of stored procedure we can create in SQL Server. In this video, let's continue our discussion on stored procedures and let's see how we can use input parameters when working with stored procedures. So stored procedures can use input parameters. Input parameters like allows us to pass values when executing the procedure. So these parameters make the procedure dynamic. So it can return different results based on the input provided. Okay, so what we can create, right? Like we can create something like get employees by ID and that will accept the parameter employee ID. And based on this employee ID, we will return the employee. Let's create this procedure in our SQL Server. So I'll copy this and let's execute this here. So get employee by ID. I am taking employee ID as the input parameter. Let's execute this here. Now, to execute the stored procedure, I can say exec or I can say execute. Then I can put the procedure name. First of all, I'm getting this red line here because we have not supplied the employee ID parameter and that is mandatory parameter. So I have to supply one input parameter here. So let's say one here. If I execute this, I got the employee ID 1 Alice, and if I pass 2 here, I got the second employee, that is Bob. So based on the employee ID, we can return the result, right? But if I don't supply this parameter here and execute this, I will get the error, right? Because this is a mandatory parameter. We can execute this by using this statement get employee by id, and we can pass 1 here. Let's see what are the mandatory parameter. A mandatory parameter must be provided when executing the stored procedure. If you don't provide the value, SQL Server will return an error. That's what we have seen here. So this is the error you will get if you don't supply the appropriate parameters to the procedure. Okay, so let's see the example of this also. Get employees by department. Let's copy this and let's paste it here and create this procedure also. So this is also very straightforward procedure, that is taking the department, and based on the department we are returning the employees. Okay, so in order to execute this, we can say get employees by department and pass the department like this. So what I can do, I can execute get employees by department and pass the IT department here, right? I will get the data. But if I don't pass it here, let's see what will happen. I will again get the error. But let's say I want to make this optional parameter. For that, what we can do, we can use optional parameter. So let's say this procedure where I have this get employees procedure that is taking the department, but I specified a default value for this, that is null. So even if we don't pass the value, the default value will be picked by the procedure. Let's see this also. Let's create this procedure. I will copy this and put it here. Let's see the SQL also, what we have in this. So select start from employees where department is equal to the department which is passed by the user, which is supplied by the user, or department is null. So if the department is passed as null, in that case, we will return all the employees. Okay. Now let's execute this. So I can say exec, and let's say I will give the name as get employees, and let's pass the department as HR. Okay, let's execute this. I got the employee Alice because employee belongs to HR department. But if I don't supply any parameter, I will not get any error. This time this parameter was passed as null, so the default value will be picked, and this default value will be null, so this condition will be true. That's why we will return all the employees from the employees table, right? So we have seen how we can execute by passing the parameter, or we can pass without passing any parameter also. Okay, now let's see how we can pass parameters. There are three ways to pass parameters to stored procedure. One is positional parameters. Positional parameters means we can pass the parameter by the position of it. So if you see here, the department ID is coming at the first position. So I can pass department ID, the department name here, right? Let's suppose this procedure is having one more parameter. Let's say it is having name also. Change it to the employee ID. So let's say this is employee ID integer, and I can use this parameter also inside this, and employee ID equal to the whatever we are receiving in the input parameter. Okay, so if I alter this procedure, let's say create or alter, and let's execute this. Now this SP is expecting two parameters. One is the department, second is the employee ID. So I passed the IT department here. I can pass the employee ID also. Let's say one here. If I execute this, okay, so there is some issue with the logic. So I have to specify this condition and this particular condition. Let's alter this procedure again. And now you notice it will not give us any data. Why so? Because there is no employee who is having IT department as their department and ID as one. However, if I change it to the HR, I will get the data, right? So I can get the data. This is the employee ID 1, department HR. So The point is I can pass the parameter using the position. So the department is at first position. I can pass first department. Second one is the employee ID. So that will be the employee ID. I cannot reverse the position. So if I change it here, like if I change it employee ID first and then the HR department, I will receive the error. Now let's try to execute this. You see I'm getting this error, not able to convert varchar to integer, because at second position I'm specifying HR and the second position belongs to employee ID, that is integer. So we are not able to convert this HR to an employee ID of integer type. That's why we are getting this error here, right? So this is how you can pass the parameters using the position of the parameter, right? And the second method is the named parameter. You can explicitly specify the name of the parameter. So like I want to specify this as my employee ID. So I can say employee ID is equal to 1, and then I can specify department is equal to HR. So this is called the named parameter. So if I execute this, this will work just fine. Okay, so this is a named parameter way. So I can pass the variable using the named. This is the recommended way for the readability, because here we can see what value is passed for which parameter. Okay, third one is the mixed parameter, where we can pass the parameter mix of positional and the named parameter. Right, so let's see this example where we have this procedure get employed by salary. So we have specified minimum salary. This is a mandatory parameter, whereas we have the department that is an optional parameter. Why optional? Because we have some default values set here. What we can do, we can pass the minimum salary. So we can pass the minimum salary, meaning one parameter I can pass here. So that will also work. I will get the data, or I can specify the salary along with the department name. That will also work because this parameter is an optional type. So here is the summary. So mandatory parameter, these are the one which must be provided. Optional parameter that can have a default value, right? Position parameter that will be passed by the order. I mean, we have to follow the same order or the sequence in which the variables are declared in the procedure, and the same order we need to follow when executing them. Named parameter, this is the most recommended way. So we can pass the parameter by passing the name of the parameter and the value of it. That's it for this video, guys. In the next video we will see how we can define output variables in SQL Server stored procedures.
Hello and welcome. In this video, let's understand what is output parameter in SQL Server. Previously, we have seen stored procedures where we have defined input parameters. If you see this stored procedure which we have created in the last video, get employees by department, this is expecting one department as the input, and based on this department, we are returning the employees. So I can execute this SP by passing this input parameter and execute this. I will get the employees who are working in IT department. Now, let's say I want to get some output from this stored procedure. Instead of this result set, I want to get a single output from this stored procedures. So let's see that also. So what is an output parameter? An output parameter is used to return a value from stored procedure back to the caller. So whenever we will call this stored procedure, we can send some output to the user using the output variables. Okay. Unlike select statement, it returns a single value with the help of a variable. Okay. Let's see this with an example. So this is one very simple procedure where we are getting the employee count and we have this variable total employees. This is the data type of this variable and we have used the output keyword here. Okay. Let's try to create this in SSMS. So I will copy this. Let's paste it here and let's create this stored procedure. Okay, so the stored procedure has been created and this is expecting a one output parameter that is total employees. Okay, so what this will basically do, this will go to this employees table and take the count of all the rows and set it to the total employees variable. That's it. Now let's see how we can execute these kind of stored procedures. So normally we can pass the input variables like this, right? So input parameter can be passed like this, but for output parameter, there is some different way. So let's see that also. For output variable, first we need to declare a variable. So I have declared this variable integer, and then we have to pass this variable as a named parameter, right? So let's see this in example, how we can do this. I'll copy this and I will put it here. Okay. So what we are doing, we are first declaring a variable count, and we are passing this count as the variable here to the total employees, that is parameter. So understand the difference. This is the parameter name and this is the variable name. And while passing this parameter also, I need to specify the output keyword here. And finally, I am selecting this count. We can print this variable also if you want, but let's go ahead with this example. If I execute this, you see, I'm getting the 4 here. 4 is our total employees. And this output is very important. If I don't pass this as output, see what will happen. If I execute this, I will still get the null values because the output keyword is mandatory here, else it will not set the value which is coming out of this stored procedure. So this is the named parameter way. So we can pass the parameter as the by passing the name of the parameter and then the variable, and we can do it without this also. So if I remove this from here and pass the count like the output, let's execute this now, I will get the same result. So we can pass this variable like this also. Now let's see one more example. Here I am taking one input parameter as well as I have one output parameter also. So I will be taking department, and based on the department I will be counting how many employees are working in that particular department. Let's see this particular example also. So I will copy this. So I am saying create procedure. I am having one input parameter, that is a department, and one output parameter, that is total of integer type, and again I have declared this as output parameter by using this output keyword. And the logic is very simple. We are calculating the employees based on the department and setting that to the total, right? So we can set this total variable here, right? Now let's see how we can execute this kind of procedure where we have input as well as output variables, and that is again very simple. If you see here, let's copy this, paste it here. So what we are doing, we are declaring one variable result. Then we are passing two parameters here. One is for department and we are using the named parameter. And it is always recommended to use a named parameter because this is very easy to read and easy to understand. I can see which parameter is having which value. Okay. So department variable. So the department parameter, we are passing IT value. For total parameter, I am passing this result, and I am also using this output keyword here. And finally, I am selecting this. Okay, let's print this result in this case. So I print this result. Let's execute this. Okay, so we are not able to find this SP. Oh, I think we have not executed this particular code. So let's first create this procedure. Now let's try to execute this. And we are getting 2 because there are 2 employees who are working in the IT department. If I change the department as HR and execute this now, I am getting 1 because there is only one employee who is working in HR department. And guys, we can have multiple output parameters also. Like in the earlier example, we were having only one output parameter, right? We were having this as the total as output parameter. Here we were having total employees as output parameter, but similar to this, we can have this two output parameter like we have here, minimum salary and maximum salary, and then we can set the minimum and maximum within the stored procedure. And finally, we can execute the SP by like this, like first declaring the variables and then selecting these variables. Let's see this also in SSMS. So I'll copy this and let's create this SP first. Get side stats. So this will return us minimum and maximum salary. Okay. And to execute this, that is also very simple. What we need to do, we need to create two variables, minimum and maximum. And when executing this stored procedure, I need to pass both of these variables for this parameter. So minimum salary parameter is taking min, maximum salary parameter is taking the max. And I have used this output keyword for these parameters. Okay. Let's execute this. Right, I'm selecting minimum salary and maximum salary from this employees table, right? So this is how you can work with multiple output parameters. So key point to understand here is you must use the output keyword when defining it in the procedure and when executing it. So that's what we have done here. If you see this example, we have defined the output keyword when defining this parameter, and when executing this also, I have to use this output keyword. So output parameter will return single values, not the result set. It is useful for like checking the counts, status flags, or for some calculations. So here is a quick comparison between the select and the output parameter. So what the output parameter will return, it will return a single value. Select will return a result set. So it can send the set of rows with the select clause. So usage, like we have to use the variables, but for the select we can directly send the output like we were doing here. We are directly selecting this select star from employees. Here we don't have to declare any variable. So this is basically used for count or status, and select is basically used when you want to send some multiple rows as the output. So here are some real world use cases. So like if you want to get total number of users, you want to return success or failure status, like you are inserting some employee in the table and you want to return some status after the operation has been completed, you can use output variables. For example, like you want to get total employees, total salaries, or these kind of things. You want to return generated IDs, like once the employee is generated and you want to return the employee ID created for that particular employee, you can use output variables or output parameters for those. You can perform some validation checks also. Here are some interview questions. So what is an output parameter? What is the difference between output and the return? So we have not discussed what is the return for an stored procedure. That we will be discussing in the next video. And can we have multiple output parameters? So this is also one of the interview question. And when to use output versus select? So this can also be a one good interview question. So that's it for this video, guys. The next video we will focus on what is the difference between output and the return for a stored procedure. In the past few videos, we have understood what are input parameters, what are output parameters. In this video, let's understand what is the return in stored procedure. So stored procedure can use the return statements. It is used to send a single integer value back from the stored procedure. It is mainly used for status code check, like the SP is was successful or not. It can be used for conditional checks or validation results. Return can only return integer values. It cannot be used to return data or result sets. Let's see one example here. So I have this store procedure check employees exist. It is taking one employee ID as the input parameter, and this is basically checking if this employee ID is present in our database or not. Okay. So if this exists, if we have this particular employee ID, we will return 1. If it is not available, then we will return 0. So let's create this stored procedure in our SSMS. So let's create this stored procedure. Check employee exists. Okay. So it has been created. Now let's see how we can capture the return value from the SP. How we can capture it? First, we need to declare a variable result, and then when executing this, we can set this result is equal to the SP name and then the input parameters or output parameters, whatever is applicable for the stored procedure. So let's copy this. So I have declared this result variable. See how I am executing this SP. I am using the exec keyword as before, and I have this SP name and this input parameter, right? And I'm storing the result. So whatever will be returned from this execution will be stored in this result variable. And finally, I'm selecting this result. Let's pass this 1 here. So 1 is available in the database. So we should be returning 1 from here, right? So we return the result as 1. But if I pass some random value, let's say 14989, and if I execute this now, of course this employee is not present in our employees table. Let's execute this and we have returned the result as 0. So this is how you can return values from the stored procedure. Okay, and it is very simple. You just need to use return space any number you can send. So you can only send the integer numbers from the return statement. You cannot like say return y or no. So this is not allowed. So if you try to create a procedure like this, create or alter, we should receive an error. Okay, it has been compiled successfully, but if I try to pass 1 here, And let's see if this will be allowed. So the comparison has failed. Okay, so it is not allowing us to send the y value because we can only send integer values from the return statement. So we are not able to convert this to integer. So it has to be integer. Okay, so let's convert this and now let's try to execute. We are getting 1 again. So let's see one example with some business logic. So we are validating this salary. So if the salary is less than 0, we are returning -1 because this is an invalid salary. If salary is equal to 0, we are returning 0, means the salary is 0. Else we are returning 1, it means it is a valid salary. So this is how you can use return statements when working with stored procedures. And the execution will remain same. You can use some status variable and put it in front of your SP name. So whatever will be returned from this execution will be stored in the status variable. Here are some important rules when you are working with the return statement. Return can only return a integer. You cannot return varchar or any other data type. Okay. And it can return only one value. You cannot return multiple values from the return statement. Okay. So default return value is 0 if it is not specified. Okay, and mainly it is used for status and error handling. I want to show you this default return value. So let's go to SSMS and we have this SP here, right? Get employee by department, and we were executing this here. So let's say I want to declare one more variable, declare return value RB. It is also integer, and what I can do, I can put this variable here is equal to print, or let's select at the end, let's select the return value RB. Okay, let's comment out this for now, and if I execute this, I'm getting the 0 here. So the return value will be 0 by default even if the SPs are not returning anything. Now let's finally understand what is the difference between a return and an output parameter. Okay, and this is one of the most important interview question. So let's see, the data type return can have only integer data type, whereas output parameter can have any data type. So you can return integer dates from output parameter values. So we can return single values, but with output parameter we can define multiple output parameter and we can get multiple values using the multiple output parameters. So what is the purpose of return is basically used for status and result codes. Output is mainly used for send the actual data. So return is quite limited, so we can only return like integers, but output is pretty much very flexible, so we can return any type of data from the output parameter. So here are some real world use cases when working with the return statements. So it can be used for if the record is available in the database. It can be used to validate the input parameters. It can be used to determine if the operation was successful or failure. It can be used for error handling, and it can be used for like API or database status signaling. So based on the signal that is sent from the return statement, API can decide what is the status of the operation. So the common mistake that people will do, right? If you're trying to return like return success, this is not allowed. We have already seen this. Like if we try to send some any other parameter, this will not work. When this statement will run, it will try to convert this success to the integer, and that is not allowed. So always we have to return number from the return statement. And if you want to return something like success, for this we have to use the output parameter instead of return. So that's it for this video, guys. In this video, we have understood what are return statements in stored procedures and how they are different from output parameters. Hello and welcome. In this video, let's understand the advantages of using stored procedures. Okay, the first one and the biggest advantage is execution plan retention and reusability. When a stored procedure runs, for the first time, SQL Server will create execution plan, and SQL Server will store this plan in the database. So whenever the next time we will execute the stored procedure, the same plan will be reused. We don't have to recompile the SQL again, and we don't have to build the execution plan again because database will already have the execution plan of that particular stored procedure. This will return in faster execution time and better performance. The second advantage reduces network traffic. So instead of sending multiple SQL queries from application, what we can do, we can combine all the SQL queries within one stored procedure and we can just call one single stored procedure. For example, like get employees. So whatever business logic you want to perform to get the employees, like whatever multiple SQL queries you want to execute to get the employees, you can put all those SQL inside this stored procedure, and this one call is sufficient to get the employees, right? We don't have to send multiple database calls to the database, and this will benefit us, like this will have less data transfer and faster communication. Code reusability and maintainability. This is also one of the biggest advantage of using stored procedures. So we can write our SQL logic once in the database and multiple application can use it, right? Along with that, when you want to change your logic, like some business demands come and you have to modify the logic of your stored procedure, you can just go ahead and update your stored procedure. So no need to change the application code. You can just modify your stored procedure and that will be all. What is the result of this? This will result in the cleaner code and easier maintenance because you are making changes at only one place. All right. Better security. Users can be given permission to execute stored procedures only, not direct table access. In that way, we can control the data access. Okay. So this will result in safer database. So the security will be enhanced for your database. Fifth advantage is, and this is also one of the important interview question, stored procedure will help us to prevent SQL injections. Stored procedures, when used properly with parameter, it will reduce the risk of SQL injection attacks. Okay. First, let's briefly understand what is an SQL injection attack. SQL injection is a security attack where a user sends malicious SQL code into input fields to manipulate the database. For example, if you see this SQL query, select star from users where username is equal to admin and password is equal to 1234. Okay. Let's say user is entering admin as the username, and for the password they have entered this single quote or 1 equal to 1. So when we replace this admin and password in this query, what will happen? The query will look like this. Select star from users where username is equal to admin and password is equal to this particular string. So when you put this particular string here, what it will do? It will add one additional condition to our SQL query or 1 is equal to 1. So this condition will always be true and the user will be able to log in. This is called SQL injection. And I have discussed about SQL injection in one of my previous video when we have discussed Dapper, how Dapper can help in SQL injection. So there I have demonstrated what is SQL injection. So what you can do, you can go to my YouTube channel and you can search for this particular video where I have discussed like how to avoid SQL injection attacks. Here I have explained how SQL injection attacks can be performed on the database. So, how SQL Server stored procedures can help us prevent SQL injection attacks? When we are using parameters, like if we use parameters like username and password like this, in this way, user won't be able to pass that particular string. Because if we pass that malicious string, in this case, this will be rejected. So if the user will try to pass this kind of string, in this case, this will not work. Because here we are not doing this string concatenation. We are directly passing the parameters here. So this will result in safe SQL code. And to make sure you are avoiding SQL injection, you should not use a dynamic SQL in your stored procedures whenever required. And if you have to use dynamic SQL, you can use sp underscore execute SQL procedure to avoid SQL injection attacks. And what other thing you can do? You can validate the user inputs. So before executing this particular statement, you can perform some validations like if the username is valid or not, if the password is a valid one or not, and then only you can perform this particular query. Okay. So you can perform validation inside the store procedures to make it more secure, and you can only allow valid characters when validating the user input. Yeah, one more thing I want to clarify is stored procedure alone do not guarantee the safety. They are safe only when parameters are used properly. So even if you are using stored procedure, but inside the stored procedures, you are using something like dynamic SQL, In that case also the SQL injection is possible. So you have to make sure you are using the parameters and you are using the parameters properly in your stored procedure. That's it for this video, guys. From the next video, we will start our discussion on SQL functions.
Okay, so in the last few videos, we have discussed about SQL stored procedures, and now let's start our discussion on SQL functions. So first of all, what is a SQL function? SQL function is something that will perform a specific operation and returns a value. So SQL function can take some input parameter or they cannot take any input parameter. It is like basically optional. If you want to define input parameters to a function, you can define it. Else you can define a function without any input parameters also, just like with the stored procedures. Then SQL function will run and it will return some output to you. There are scalar type SQL functions. So they works on a single value. They will return a single value to you. So we have some inbuilt SQL function. In the future videos, we will also understand how we can create our own SQL functions. But for now, let's start with the inbuilt functions that are already available in the SQL Server. So let me open my SSMS and let's start our discussion on SQL Server functions. I am connected to my database. Let me explain databases first. Here I will explain my demo DB. And here you can see there is one folder programmability. Let me expand this also. Right. So here you see we have one folder for stored procedures and we also have one folder for functions. So let me expand the functions folder. We have the four types here. System defined function. So the system defined functions are available in this folder. So all the functions which are inbuilt in SQL Server are available in this folder. And we have this scalar valued function. Let me expand this also. And it is currently empty because we have not created any scalar valued function yet. And let me expand the table valued function, that is also empty. So whatever function you will create, either it is scalar valued or a table valued, that will come inside these two folders, right? But for this video, let's focus on the inbuilt SQL functions. So as we were saying, we have this SQL function upper. So as the name suggests, this will change whatever data present inside this SQL function to an uppercase. Let's see this in action. Let me copy this and let me paste it here. So what we are saying select and then the function name. Function name is upper, and then we have these two brackets, right? And then I am passing this hello world string. And finally, I'm selecting this as the result. Let me execute this. I'm getting the hello world in the uppercase, right? So this execution will give us the uppercase output. Let's see some other inbuilt functions. So we have the len function. This basically stands for the length. So if we want to check the length of a particular string, we can use this function. Let me copy this and let's paste it here. So I am executing len function and I'm passing this particular string here. So let's see the length of this string. The length is 12. If I add some characters at the end, let's add ABC and now check the length. Now the length has changed to 16. Now let's look at aggregate functions. Aggregate functions basically works on multiple rows and give us a single output. Let's say I want to see how many employees are available in the employees table. For that, I can use this count function. So let's see this in action. Let me copy this. Let me paste it here. So let's see what I'm doing. I'm saying select count star and select it as total employees. Okay, so this will be the header of the column that we will select, right? And this is totally optional. I can remove this also, so that will also work. Okay, so I am saying select count star from employees. So I want to check how many rows are available in the employees table. So I can select this and I can see there are 4 rows available in my employees table. I can verify this. I can do select star here and execute this now. You can notice here I have 4 records in my employees table. So this is how we can use count function in SQL Server. One more function, we have average function. So this will basically find the average of a column. So if I want to see the average salary in my employees table, so I can simply run this particular query. Let me paste it in my SSMS. And here, let's see what we are doing. We are saying select AVG. AVG means average. It will return the average. Average of what? Average of salary. So this will basically calculate the salary and find the average salary that is present in this table. Let me execute this. Okay, so this is the average salary of the employees, and I can include where clause also here. Like if I want to see the average salary in the IT department, so I can simply add where department is equal to IT. So this will give me the average salary within the IT department. So I will execute this, and this is the average salary of the IT department. Now let's move on and see some string functions also. String functions will help us in manipulating the string. Let's see the first one, that is concat. This will basically perform the concatenation. So if we have multiple strings, hello, and then we are concatenating, and then we are appending space, and then the word. So I want to concat these three strings into one. For that, I can use the concat function. So let me copy this and let me paste it here, and let's execute. So what has happened here? It has combined all these three strings and bring it into the one single string. So basically concat can take any number of parameters. So I can specify like 2 here. And if I execute this now, now 2 is also appended in this string. So we can pass as many argument as you want to pass in this function. Now let's see some date functions. So we have this get date function to get the current date, right? So let me copy this and execute here. So get date will give me the current date. So this is the current date, and it is also giving me the current time as well. And we have this date difference. If I want to find the difference between two dates, I can use this date diff function. So let me copy this and let's paste it here. So let's see what we are doing here. I'm calling this date diff function, and I'm passing first parameter as day because I want to see the difference in how many days difference is there, the first date and the second date. So I want to calculate the difference between these two dates, right? How far these two dates are present. Okay, so this is 2024 and this is our current date. Let's execute this. So there are 818 days between these two dates. If I want to see this in months, so I can change it to months, right? I can pass the month here and I can say months here, months past. And if I execute this, there are 26 months between these two dates, right? And if I change it to year, right, and execute this, so there are 2 years between these two. So this is how you can use the date diff function. Now let's move on and let's see some mathematical functions. First one is the round function. As the name suggests, this will round up the value and give us the result. Let's see this in action. Let's copy this and let me put it here. And let's see this value. I have this 123.456, and the second parameter I am passing it as 2. So what will happen? This will round up this value to the 2 decimal points. So when I will execute this, I will get this 460, and it has removed whatever present after 2 decimals. It has bring that to 0 and it has rounded up this value here. Okay, so if this value was, let's say, 2452, and if we execute this, then it became 2450, right? So it is able to round off the values. Okay, let's move on and let's see how we can use this in our real-time tables. Let's say I want to round up the salaries, so I can use this employees and I can use this round here. So let me copy this Let's paste it here. So I'm saying select name, and I'm selecting the name in uppercase also. Then I'm selecting the salary, and finally I'm selecting the rounded salary. Okay, so I'm passing the salary as the input, and the second one is 0, so I'm rounding up to the 0 decimal points. Okay, let me execute this. Okay, so we are not seeing any difference between these two columns because the actual salary itself is not having any decimal points. But let me update the salary. So I'm updating the salary here. I'm updating my employees table. I'm setting the salary is equal to 50,000.80, where the name is Alice. So let me execute this. Okay, now let's see the data once. So the salary has been updated to 50,000.80. Now let me execute my query again. Now you see the difference. We have the salary as 50,000.80, but the rounded salary is coming as 50,001. The rounded value, so the 0.80 is rounded off and converted to the 1. So this is how you can use a round function in SQL Server. Okay, so the benefit of using SQL function is it will simplify our queries. It will improve the readability. It will reduce the repeated logic. Like if you want to round off the values, you want to find the average, then you don't have to write your own logic. There is already logic present in the inbuilt SQL function. You can reuse that logic and use in your queries. And from the interview point of view, this is very important because SQL functions can be used in select, where, and order by clause, whereas we cannot use stored procedures inside select, where, or order by. Okay, guys, so these are the few functions that I wanted to explain in this video. But the number of SQL function present in SQL Server is very large. You can go to any online search engine and you can search for SQL functions, and you can look for W3 School's website. You can open this, and here you will get the complete list of SQL functions that are available for us to use. Like we have this format, we have left, length that we have seen in this video, right? So we have trim function to trim the leading spaces. Let's see this in action in SSMS. Let me copy this and let me put it in my SSMS. Let's see what we are doing. So I am passing this SQL tutorial string here, but there are spaces in front and in the back. But when I execute this, I will get SQL tutorial. There are no spaces here because spaces are trimmed by this trim function. Okay. So you can visit this link here. I will also provide this link in the description below so you can check it out. So here is the complete list of functions that are available. So like it has also categorized this. So we have these string functions, then the numeric functions, then the date functions, advanced functions are also there. We have cast to convert one data type to other data type. We have convert is null. Is null we have seen how we can replace null values. We have seen callis function earlier, like how we can use callis function and get the not null values. I will like to end this video here. From the next video, we will see how we can create our own SQL functions in SQL Server. Hello and welcome. In the past video, we have started our discussion on SQL functions. In the last video, we have seen some of the inbuilt SQL functions, but we can also create our own SQL function inside SQL Server. Those are called as user-defined function. A user-defined function is a function created by the user to perform some custom logic and return a value. So again, this will be very similar to the inbuilt SQL functions. So we will provide some input, like if the SQL function is expecting any input, we can provide some input and put our own custom logic and then provide the output. Okay. So again, there are multiple type of UDFs. First one is the scalar function that will return a single value. Let's see the example of this first one. So to create a SQL function, we need to use create keyword. Then we need to specify what we are going to create. Because we are creating a function, then we are saying create function. And then we need to specify the name of the function. The name is specified here as dbo dot. Dbo is the schema name that we will be using, and then the function name that will be used when invoking this function. And here it is expecting two parameter, first name and the last name, right? And then we are specifying what will be the return type of this function. I am saying varchar here, and then I'm saying as begin, and then I am writing my custom logic here and then ending it with the and keyword. Let's see this in SSMS. So I will copy this and I will go to my SSMS. Let me open a new query and let me paste it here. Okay. So this is how you will create a SQL function. And this is optional. If by default, the function will be created inside your default schema, and the default schema will be the DBO. So you can easily remove this and this will still work fine. So I will execute this. So the function has been created. Now, if you go to the left hand side and see this function folder here and right click on this and click on refresh. And then if you open your scalar valued functions folder, you will notice you have this little function here, get full name. Okay, so we have successfully created this function here. Now let's see how we can invoke this function and use this. You can use a select here and then call this function like this. So we are passing two parameters, John Doe, and we are selecting this as the output. Okay, let me copy this and let me put it here. So either you can use select, but it is totally fine. You can do print also if you just want to see the output. Okay, so you can do print also. And guys, one more thing, it is mandatory to specify the schema here, because if you don't specify the schema and try to execute this, you will get the error, because without schema, SQL Server will not be able to find out this particular function. So we need to specify the schema name here, and then we need to invoke this. So if I invoke it now, I'll get this complete name here, right? So we can perform some custom logic using our user-defined functions. Let's move on and see some other examples. One other example could be if you want to calculate the salary of your employees after adding the bonus on that. Okay. So what we are doing, we are creating this function, calculate bonus, and we are passing down the salary. And then we have added some custom logic. So we are increasing the salary as 10%. And after doing this increment, we are returning it. And look at the return type here. So we have defined the return type using the returns keyword. So notice the difference. Here we say returns with the s here at the end. And here we are using return without the s. So we are returning this. And here we are defining the return type of this SQL function. And if you notice the behavior in the last function also, get full name, we have defined the return type as varchar, but here because salary will be in decimal format, in a numeric format, so we have defined the return type as decimal. 10 comma 2, why 10 comma 2? Because it can return a number that is 10 digit long and 2 points after the decimal. So after the decimal, after the point, it can have two more digits after that. Okay, so let's see this also in our SSMS. So I will copy this and let me go to my SSMS. I'll paste it here. Okay, so let's create this. Okay, the function has been created. Let me refresh my scalar valued function again, right? And I have this function here, calculate bonus. So let's see this also in action. So I can invoke this by using select. So I can call this by using the name of the function dbo.calculate bonus. I'll put it here and let me pass some random salary. Let me say 2500 here and let's execute this. So the salary after bonus will be 2750, right? So this is how you can write your own custom logic and perform some calculation and get the output from the SQL functions. So these are the user defined functions. Let's move on and see some other examples. So we have table value function, and table value function are further categorized into inline table value function and multiple line table value function. And the table valued function, as the name suggests, will return a table as the output. We were seeing here, these were the scalar type functions. So they were returning a single value as the output. So when we were running this get full name, we got this single output, right? But in the table valued, you will return a table as the output. Let's see this also in action. So we are creating this function here with create function, and the name of the function is get employees by department. So let's copy this first and then we will understand what is happening here. Let me put it here. Okay, so let's see what is happening here. So I'm creating this function and then I'm expecting one parameter, that is department ID, and then I am selecting name, salary, and the ID of the employee. Okay, and I'm getting it from the employees table by passing the department ID equal to department ID. And here, if you notice, right, I am returning a table, returns table. Okay, so I'm not saying like return decimal or return a varchar. I'm saying returns table. So this will basically return a table from this. Okay, we need to make some changes here because our employees table is having some different definition. So let me remove the ID from here, and the department is a varchar in our table. So I'll say department here, and I will change this here to department, and I'll change it to varchar because in our table department is a varchar type. So let me say varchar 10. Okay, now let's create this function. Okay, it is saying there is already a object with name get employees by department, because if you remember in the last video we have created this stored procedure with the same name, so you cannot have a function with the same name as earlier. So let me change this little bit. I'll say dept here. Okay, so get employees by DEPT, which is basically department. I'll create this. This time we are able to create this function. Now let's see how we can invoke this function. So we were doing this select here to get the output. We were able to do print also, but for table valued, we have to specifically use this select, and we also have to use select star from, because this will basically return a table, right? So how we will select a table? We will do select star from, then the table name. Similarly, we need to use like select star from, and then I will specify the my function name. So this is my function name, get employees by department, and I can pass my department name here. Let's say I want to get the employees from HR department. So I can invoke this like this. I got Alice because Alice is working in HR department. If I change my department to IT and execute, I'll get Bob and David because these are the two employees who are working under IT department. So we have seen how we can invoke a table valued function. And remember, this is inline table valued function because, so what we have done here, right? We have returned this particular output. So if you see earlier, we were using begin and end, and then we were returning something. But here we have not used the begin and end keyword. We have directly returned the data from here. So this is a single line, or we can say inline table valued function. Okay, we have multiple line table valued function also. We call it multi-statement table valued function, or MSTVF in short, that will return the table using the multiple statements. Let's understand this also with an example. So I'm creating this function. I'm specifying the function name. Then I have the input parameter. This is same as before, but here when returning, like when I'm saying returns, I'm not saying table like I did before. Here I specified table here, right? But here what I'm doing, I'm specifying one variable that is of table type, and then I specified the definition of the table. Okay, so the definition is I am returning ID, name, and the salary of the employee. And then what I'm doing, I'm inserting the data. Let's copy this, and then I think we will understand this in a better way in SSMS. So I'll copy this. I'll go to SSMS. Let me open a new query and let's paste it here. Okay. So what we are doing, we are creating this function. Then we have defined the return type here as a table. And then we are inserting data inside this. So what I'm saying, select data from this table and insert whatever data is emitted by this select query, insert that data into this result table, and finally return from here, right? So this is how this will work. So this will basically insert data in the result variable and we will return from here. So this is how we will get the output from this type of SQL function. And again, I think we need to modify this function somewhat because the employees table is not having ID here. So I'll remove this. I'll remove this ID from here also. So what we are doing in this function, we are getting the employees who are having salary, which is either equal to or greater than the minimum salary that will be provided by the user here. So we are trying to get the employees who are earning more than or equal to that particular salary amount. Let's create this function. Let me refresh this scalar valued function. You will notice here that new function is not coming here, right? That will come inside the table valued function. If you expand this, you can see here, get high salary employees is coming here. Okay. Now let's see how we can execute this. First, let's see the data in our table. Select star from employees. Okay, so we have this data here. Now we can again invoke this like we have invoked our inline SQL function. So I can say select star from dbo dot get high salary employees. So this will be my function name and I can pass the input. So if I want to get the employees who are earning more than, let's say, 1,000. So basically all the employees are earning more than 1,000. So I should be getting all the results from here. So if I execute this, so I get all the 4 employees. But if I increase this amount, let's say get all the employees who are earning more than 58,000. And if I execute this now, I got only 2 employees here, right? So our custom logic is working as expected. So we have seen what are inline table value function, where we will have the returns as table. Then with one single line, we will return the data. Then we have seen multi-statement table value function, where the return type will be a variable result. Then we will define the structure of the table that we want to return, and then we will insert data in that table. Then we will finally return from that SQL function. Okay. So this is how we have seen how we can invoke these type of functions using select star from, then the table valued function name. Okay. So we can use our user defined functions within the queries. Like earlier we have created this calculate bonus function. Let's see how we can use this inside our select query. So what we can do, we can do select. Let's copy this first, then we will understand what is happening here. So I am saying select name and then the calculate bonus with salary. Let's select the salary also, then we will see what is happening to the salary. So I have the salary and then I also have the salary with bonus. Let me execute this. We can see this was the salary before bonus and this is the salary with bonus. So salary has been increased by 10% because this was the logic was added here. We are increasing the salary by 10%. Okay. Now let's move on. We can create some functions using conditions. So what I'm doing here, I'm creating a function get grade where I will input the marks, and based on the marks, I will like output what grade of the what will be the grade of the like student, right? So let's copy this, go to SSMS, and I will open a new query window. Let me put it here. You can look at this returns statement. It returns a varchar. it is a single value. So it is a scalar valued function. So if I execute this, I will see this in my scalar valued functions folder. So if I execute or refresh this here, I can see my get grade function is coming up here. And we know how we can execute our scalar valued function. Either I can use select dbo dot get grade. Okay. Let's pass some marks here. And I'm getting a red line here because the IntelliSense is not able to identify this. To resolve this issue or this warning, what you can do, you can go to edit and go to IntelliSense and you can click on refresh local cache. Once you do this, after a few seconds, you will notice this red line will be gone. Now you see the error is different. Now it's saying insufficient number of arguments because we have not specified any argument here. So let's say 50 here. Okay, now the error has gone. And if you see our logic, if the number is 50, if the marks are 50, then the grade will be C. So I will get C here. I can print this also. So this is the benefit of a scalar valued function. You can either print them or you can do a select also. So if I print, I'll get C here. And if I increase my marks here, let's say 75 and execute, I'm getting the B grade. Okay, so our SQL logic is working as expected. Okay, let's move on and see some UDF with date logic. So we can use this to calculate the age of someone, like we can pass the date of birth, and we have seen this date diff function earlier. So based on this, we can calculate the age of some person. And here are some key points that you should remember when you are working with user-defined functions. User-defined functions allows reusable custom logic. You can create a scalar single-valued user-defined function. You can also create ITVF, that is inline table valued function, that will return simple tables. You can also have MSTVF, that is multi-statement table valued function. If you have little bit complex logic, for that you can use multi-statement table valued functions. So SQL function basically can be used along with select, update, delete, order by, or where clause. Hello and welcome. In this video, let's understand what is the difference between a stored procedure and a function. So in this video, we are going to cover all the main differences which is available in a stored procedure and a function. So I will be covering 7 differences. And guys, this is one of the most, and I mean very most important topic that will be asked in a interview. So you should always know when to use stored procedure and when to use a function. Let's start this video and let's start with the return type. Okay, so as we have seen, stored procedure can return multiple values. They can result sets or they can result output parameters also. And they can also return a return value that we have seen in earlier video. So let's connect to SSMS and see this with an example. I have connected to my database. Now let's see how we will create a procedure. So we will say create procedure and we will provide some name to this procedure. Let me say sp underscore test 1. Okay, and I can provide some input and output parameters here. Let's say this is my first input parameter p1. I will call it as integer type, and let's keep this as one input parameter, and I will say as begin and then end. Then what we can do, we can return some result sets here, like I can say select star employees, right? This I can do. If I create this procedure here and if I execute this sp underscore test 1 and I will pass some input parameter, let's say 10 here, and let's execute this. I'm getting this result set as the output, and I can return multiple result sets also. So I can say sales 2024. Okay, so this table is available. So I can say this also, select star from employees and then select star from sales 2024. If I modify this procedure with alter keyword, let me modify this. Let me execute this. So I am returning two result sets. So I can return multiple result sets also. Apart from this, I can also return output parameters that we have seen earlier. So I can say p dash 2, let's say input, and I can say this is output also, right? So I can define output parameter also. So within the SP I can set is equal to 20. So I am setting this output parameter to 20. If I alter my SP again, now let's pass this output parameter. Okay, so I'm selecting this output parameter and I'm passing it here in my SP. And if I run this SP now, I'm getting this 20 as my output parameter. So I am able to return result sets. Along with that, I'm also able to return a output parameter. So I can define multiple output parameters also, just like we are able to return multiple result sets, right? And even after outputs and the result set, we can also return the return values that we have seen. So I can say return 10, right? So this is also possible. So if I want to capture this return value, I will first alter this SP, and let's see how we can capture this return value. So I will create one more parameter, and sorry, this is not parameter, this is the variable. So I'm creating this variable return value RV, and I can say RV equal to whatever result will be returned from this will be stored in this RV variable. So let's select the RV also at the end. Okay, let's run this now. And I'm getting 20 as my output parameter and 10 is my return value. So we are also able to return values from here. So we can send output parameter, we can send result sets, and we can also send the return values. So these are the three type of data we can expect from a stored procedure. On the other hand, functions can only return a single value or a table. If the function is of type scalar type, they can only return a single value, or they can return a single table data set. In the previous videos, we have seen how we can create scalar functions and table valued functions. Now let's move on and let's understand the second difference. Stored procedure cannot be used inside a select statement or update statement or delete. Basically, in any query, we cannot use these stored procedures. Let me show you with an example. So we have some functions here. Okay, let's try this calculate bonus function. So I can say select star from employees, right? And I can also call a function in this select. I can say dbo.get, or I can say calculate bonus, and I can pass the salary in this, right? And if I execute this will work just fine because we are allowed to use functions with the query. Like in a select query or update query, we can use our functions. Whereas if I replace this with a procedure, let's pick one procedure. Let's say I will use check employee exists here. So if I try to execute a procedure here, let's see what it will accept. It is taking the employee ID. So I will try to pass employee ID here. Let's pass the employee ID as 101. If I try to call this here, we will get the exception or the error message that says incorrect syntax near 101 because we are not allowed to call stored procedures in a query, right? So this is the second difference. SP cannot be used inside select or any other query. Functions can be used inside select or any other query. Now let's move on and understand the third difference. Stored procedure will allow input parameter, output parameter, right? But in functions, we can only have input parameters. We have seen this just now. We are able to add input parameter and output parameter for a function. But when I try to create a function, so I can create this function here, right? So it can take one input parameter, but if I add one output parameter here, let's say p2 int output, and try to alter this function now, this is not allowed. So we are not able to use output keyword in the function. So let's move on and see the fourth difference. That is also one of the most critical difference between a SP and a function. SP can perform insert, update, and delete. However, functions cannot do these operations. They cannot modify database because they don't have a right access on the database. So if I try to update here, like I can say update and try to create this, right? It will give us the error. Okay, let me remove this output also and try to create this now. I will put the return statement at the end. And if I alter this now, Okay, so we're getting this error, invalid use of side effecting operator update within a function. So update is kind of a side effecting operator because it can modify the state of database, right? So it is not allowed inside a function. So we cannot use insert, update, delete inside a function. However, we can easily do this inside a stored procedure. So if I copy this and put it in my SP here and try to modify this SP, it will not give us any error. Commands completed successfully. So we can perform update, insert, and delete inside the stored procedures. Let's understand the error handling. That is the fifth difference that we are going to discuss. So stored procedure supports try catch, right? So we can use error handling inside the stored procedure. So I can say uh, begin try here, and I can say and try, and I can say begin catch and catch. Okay, let's print something here. So we are able to use this begin try and begin catch inside the stored procedure, right? If I modify this SP, it is working just fine. But if I add this begin try and begin catch in my function, let's see what will happen. Begin try, begin and try, begin catch and catch, and let's print here error, or let's return 5 from here and return 6 from here. So I'm trying to use begin try and begin catch inside my function. Let me try to modify this, and we are getting this error. So again, the invalid use of side effecting operator begin try. So we are not allowed to use begin try inside the function. So let's move on to the transactions. So inside procedure, we can use transactions, and function will not allow transactions. So inside my SP, I can also say begin transaction, and at the end, I can say commit transaction. And if I modify this SP, this will work fine. But if I try to add these keywords in my function, if I remove this and let's begin transaction and commit transaction, let's say return 4 here. And if I modify this function, I will get the error. Again, this is a side effecting operator begin transaction, so it is not allowed. So basically we cannot use transactions inside a function. Now let's see the seventh point, that is execution. That is a very simple difference. So basically we will invoke our stored procedures using the exec or execute keyword. However, you will execute your functions using the select statement, or you can use the print statement also if it is a scalar type function. Now let's discuss the performance aspect of this stored procedure and function. Stored procedures are faster for complex operations. So if you want to perform some business logic that is complex, you want to update multiple tables, insert in multiple tables based on some conditions, then you can make use of stored procedures. And stored procedures are better for bulk data processing. At the same time, a function can be slower. So if you're using scalar functions inside a table, that can be slower because they have to execute row by row. So if you see the example here, let me go to my database again. Here we were executing the function. Let me use dvo.calculate bonus, and I will provide the salary here. So when I execute this, let me remove this 101 from here. Okay. So when I'm executing this, what is happening? It is executing this calculate bonus for each row. It will take first salary, calculate it, second salary, then again it has to do this calculation. So scalar functions will be invoked row by row. So that's why it can be slower depending on the logic that you're using inside your function. Inline table functions can perform better than the multiple line table functions because there the logic will be very simple. You are only using one line of code to return the data. So that's why inline table functions can perform better than the multiple line table functions. Now let's understand the ninth difference, that is where you should use stored procedures and where you should use functions. So stored procedures are suitable for performing business logics. For data manipulation, you want to update or insert some data. For complex workflow, like when you are creating a new employee in your database, you want to perform some other workflows as part of that. So that you can perform as part of stored procedures. Functions are basically good when you want to do some calculation, like we have seen here when we were calculating the bonus, we have used this function. So functions are suitable for these kind of use cases. And reusable logic inside queries, like if you are writing a query and there is some reusable logic, you can put that logic inside the function and that will make your query more readable. If you see the example here, so there is some logic to calculate bonus, but here we are not able to see that logic, right? So the query is looking more clean and more readable. So these were the 9 differences that I wanted to cover in this video, and I want to give you some bonus differences also. So in the stored procedures, you are allowed to use the print statement. So if I remove this and if I say print and let's put it in single quotes, let's alter this SP now, right? And now if I execute my SP, I'm able to get this print message, right? However, I cannot use print inside the function. So if I do print here and let's say hi to here and let's execute this, we will get the error because print is also a side effecting operator. So that is not allowed in the function. Let's finally see the summary. So return type, we can have multiple return type like result set, output parameter, return value, whereas function can only return a single value if it is a scalar type function or a table if it is a table valued function. Select usage, so we cannot use stored procedure in a select. However, functions can be used inside a select query. Output parameters are allowed in SP but not allowed in function. Data manipulation or data modification is allowed inside a SP but not allowed inside a function. Transactions are allowed inside procedures but not allowed in function. Error handling, again, it is allowed in stored procedures but not allowed in function. Okay guys, that's it for this video. In this video, we have understood all the differences between a stored procedure and a function. Hello and welcome. In this video, let's understand some of the string functions that are available in SQL Server. First one I want to discuss is the left function. As the name suggests, this will return the characters from the left hand side, meaning from the start. For example, if you have some string like SQL tutorial and you want the first 3 characters from the starting or from the left hand side, you can use the left function. I will copy this. Let's go to database and let's remove everything and paste this. So I'm calling this left function. So this is a inbuilt function. So first I'm passing my string and then I'm passing 3 because I want 3 characters from the left hand side. If I execute this, I will get the SQL, right? So this is how the left function will work. Similarly, we have the right function. So if I change it to right and execute this now, I will get the last 3 characters, meaning the last 3 characters from the right hand side. Okay. So I can increase this, let's say 6 here. If I execute this, I will get the last 6 characters. So this is how we can use a left function and a right function. Now, let's see the purpose of substring. As the name suggests, substring will give a part of the string. Let's copy this and see what will happen here. So what I'm doing, I'm calling this substring function and it is taking 2 parameters. One is the starting position from where we want to start. So we will start from the 4th character. Let's count from the start. 1, 2, 3, 4th. So at 4th location we have T. So we will start from T. And from T we will capture 5 characters. So we will capture 1, 2, 3, 4, 5. Till R we will capture the string. Okay, let me execute this. I'm getting tutor because this is what is available at this position. In most of the programming language, indexes starts from 0, but in SQL Server, index starts from 1. That's why when we said substring from 4, it will take 1, 2, 3, 4. It will not start from 0. Okay. So this is the purpose of substring function. Okay, next one is char index. So char index basically will find the position of a substring within a string. Let's see this with an example. Let's say I have this string here, SQL tutorial. Again, I'm taking this string and I want to find from where tutor is getting started. So I can execute this and you see I'm getting 4 because at fourth position this particular string is getting started. Let's say I want to see the index of q, so I can pass q here, and if I execute this now I'm getting 2 because q is present at the second position. Let's say I want to find the index of l. Okay, so if I put L here, I will get the index of L, that is 3. But you see, I have a L at the end also. So what I can do, right, in the char index, I can provide from where I want to search. So if I say 5 here, so what it will do? It will start from the fifth position. So I will go 1, 2, 3, 4, 5. So it will start from U. And within this string, it will try to find the L. If I execute this now, I will get 11 because at the 11th position I have the L, right? So you can pass the starting position also in the char index function. In this video, let's understand some of the advanced SQL string functions that we have in our SQL Server. First one that I want to discuss is replicate. That will basically replicate the string multiple times. Let's see this with an example. So what we are doing, I am calling this replicate function, and this will take two parameters. First one is the string that you want to repeat and how many times you want to repeat, right? So if I execute this, I will get SQL 3 times. If I say 30 here and execute this, so I will get SQL 30 times. So yeah, this is how replicate will work. Let's move on and see the next function. Next function is space. This will add basically the space characters. Let's see this with an example. Okay, so I have two strings, hello and world, and I'm calling this space function, and I'm passing 5 here because I want to make hello and world apart with 5 spaces. Okay, let's execute this now. You will notice, so hello world is getting selected, but there is space between hello and word, and this space is exactly of 5 characters. So I can change this also. If I say 15 and execute, so I will get hello world, but there will be 15 spaces between these two words, right? Okay, so this is the purpose of space function. Now let's see the pat index. So this will basically search with a pattern. So if you want to find a string with some pattern, for that you can use it. So let's see this with an example. I will copy this and let's paste it here and see what is happening here. So I have this email ID, and the first parameter will be the pattern that I want to search within this string. So I'm saying pat index percentage at the rate percentage. So I'm checking if this string is containing any at the rate symbol. If I execute this, I'm getting 5 because at the fifth position, 1, 2, 3, 4, 5. At the fifth position, I have the at the rate symbol. Let's see one more example here. Okay, so I am passing this particular expression here. This is basically checking for the numbers. So in this string, if we have any number, this will return the index from where we have the numbers. So if I execute this, and I'm getting 4 because at the fourth position I have a number. If I add some string here, let's say ABC, and if I execute now, the index is changed to 7 because I have appended some string in front of it. So the numbers are now starting from the 7th position. Okay, then we have the replace function. This is also one of the most used function, and this will basically replace one string with another string. So let's see this with an example, and let me put it here. So I'm calling this replace function, and first parameter is the string, so I am passing hello world here. Second parameter, basically it will search for this particular string in this string. So basically second character is the thing that you want to search in this string. Okay, so I want to find the world and want to replace it with SQL. So if I execute this now, I will get hello SQL because world is now replaced with the SQL. Okay, so this is how you can use a replace function. Now let's see the stuff function. Stuff function will basically delete a part of the string and insert a new text on that. Okay, so it will take basically four parameters. First, the string that you want to pass, starting position and the length, right? From the start position, how many characters you want to pick, and it will insert some new text there. Okay, let's see this with an example. So I am passing this hello world, and from the sixth position I will capture 5 characters and I will replace, or I will stuff SQL there. So I will remove whatever is matching in this position and I will replace it with the SQL. So if I execute here, I'm getting hello SQL because word is now replaced with SQL. So this is similar to replace, but here we are sending the indexes, like from where we want to start and how many characters you want to replace. So this is how stuff function will work. Now, let's see some of the real-time use cases of these functions. Let's say you want to mask someone's phone number. You don't want to display the complete phone number. You only want to display the last 4 digits of a phone number. For that, you can make use of write function that we have discussed in the last video and the replicate function. Let's see this in action. Okay, so I'm calling this replicate function and I'm calling this write. So let's see what will happen. So replicate 6 will basically generate x 6 times, right? If I just execute this particular thing, I will get x 6 times. And what write will do? Write will pick 4 characters from the right hand side. So what will happen? It will pick last 4 characters, correct? If I execute this together, so first we will generate 6x and then we will pick 4 characters from the right, and with the plus operator we will merge these two strings together and finally select it. So you can use this replicate and write function to do the masking. Let's see one more example to remove special characters from a string, right? So if you want to replace, let's say, at the rate from this string, you can use replace function. Let's see this with an example. So I have this hello at the rate world. I want to replace at the rate with blank string. So I just want to remove at the rate here. If I execute this, I will get hello world without that symbol in the middle. So we can use this to find special characters within a string. So I can use pat index. Let's see what is happening here. I'm calling pat index and I am specifying this expression here. So what it will do, it will ignore all the characters from A to Z, from capital A to Z, and from 0 to 9. And if there is anything that is present apart from these characters, that will be selected. Or we will get the index of that particular character if it is not from this expression. Let's execute this. I'm getting 6 because at the 6th position I have this at the rate symbol. Let's say I have put some like pound symbol at the front. If I execute this now, I will get 1 because at the first position itself I have a special character. So you can make use of pat index function to find if there are special characters present in your string or not. All right, let's move on and let's see how we can insert space in a string. So we have this hello world and I want to put a space in between these two words. So I can use the stuff function. Okay, let's see one example where we have invoked these 3 functions together. Let me copy this and let me select name also, and let's see what is happening. So name was Alice and then we replaced A with the at the rate symbol. So the name will become like this. Then we use the replicate to append like stars at front of the name. Okay, and then we have used this pat index to find the position of A in the name. In this video, let's see some of the datetime functions that are available in SQL Server. First one that I want to discuss is get date. That will basically return the current date time. So what we can do, I can go to my database and I can say select get date. If I execute this, I will get the current system date time, right? Because in my machine currently the time is 1540. So that's what I'm getting here. So this is how the get date will work. It is very simple function and mostly used in the SQL Server to get the current date and time. And we have this current timestamp also, current underscore timestamp. This will also give the same time as the get date, but this will follow the ANSI standard. So if I copy this and execute this also, I will select both of these, get date and current timestamp. I will get the same thing, but this one basically will follow the ANSI standards. Then we have the sys date time, which stands for system date and time. This will return the date and time with higher precision. Let's copy this and let me put this also. So I am executing get date and sys date time. Let's see the difference between these two. So with the get date, you will get the seconds at the 0.393, only 3 decimal points, but here you are getting more decimal points. So this sys date time will give you more precise date and time. Sys time offset, it will return the date and time with time zone offset. Okay, let's see this also with an example. Okay, let me execute both of these. So I am calling, when I'm calling this sys date time offset, I'm getting this plus 5 and 30 because my time zone is ahead 5 hours and 30 minutes from the UTC time zone. That's why I'm getting this also. So this is the difference between sys date time and sys date time offset. Basically both will give the same time, but here you will know like in which time zone you are working. Then we have get UTC date. If you don't want your local date and time, then you can use get UTC date function. And if you execute this, you will get the time and date, but this is not your local time. This is what the UTC time zone, right? So you will get the UTC time using this function. Similar to this, we have sys UTC date time. Again, it is pretty much similar to the get UTC date, but here you will get the time more precisely. If I execute both of these, you will notice here I'm getting 3 decimal points. Here I'm getting more decimal points. So this is more precise. So here is the key differences between all these functions. Get date will give you time of local zone and precision is normal here. Get current timestamp is also same. Sys date time will is also giving you local time zone, but here you will get the higher precision. Sys date time offset will give you local time plus the offset, meaning in which time zone you are working. If you notice, when I was executing this here, sys daytime offset, I am getting this plus 530 also, correct? So this is what the offset is all about. Then we have the get UTC to get the time zone of UTC. Similarly, we have sys UTC datetime that is same as the get UTC date, but with the higher precision. In this video, let's understand some of the other date functions. So first one is the is date. As the name suggests, it will check if the given string is a date or not. Let's see this with an example. So I'm calling this is date function and I'm passing a valid date here. Let's execute this. I'm getting 1 because this is a valid date. But let's say I will change this date to 45 because 45 is not a valid date. And if I execute this now, I will get 0 because this is not a valid date. So you can validate your dates using is date function. Then we have the day function. Day will basically find the day from the date. Let's copy this and let's execute this. And if I run this, I'll get 15 because 15 is the day value present here, right? If I change this to, let's say, get date and execute this now, I'll get 5 because 5 is the date. And similarly, I have like a month here. If I want to find the month, because currently we are in the 4th month, so I'm getting 4 here, and I can say year also here. to get the year part from the date. I'm getting 2026. So we have seen the month function. We have also seen the year function. Now let's see the date name function. This will return the name of the date part. Okay, so I can say date name and I can pass month and then the date. Let's see this in action. If I execute like this, I'm calling date name function, then I'm passing month because I want to find the name of the month, and then I'm passing a date here. Let's execute this. I'll get January. Let's move on and let's see like how we can find the weekday. Here I can change this to weekday, and if I execute this, I'll get Wednesday because on this date we have Wednesday. Let's continue our discussion on date functions and let's see the date part function. This will basically find the part of the date. So we can use this date part function and we can pass year. This is pretty much similar which we have seen earlier. So earlier we were using this particular function here. So we can provide the part that I want to extract. I can pass month here to get the month. Similar to this, we have this date part function. So let's see this also. So I can copy this and I can come here. If I want to say, let's say I want to find the day, then I can find day using this. I can provide month to this function to get the month. So this is the first month. Similarly, I could have the year also. I can pass year also here and to get the year part from this date. And date part can also take something like weekday. So if I want to find the weekday of this date, right? So I can execute this and I am getting fourth. Why fourth? Because when we ran this date name function, we were getting Wednesday, and Wednesday is basically the fourth day of a week, right? Because week will start from the Sunday. So Sunday will be 1, Monday will be 2, Tuesday will be 3, and Wednesday will be the fourth day of the week. So that's why we are getting 4 here. Okay, let's move on. We have the date add. So if you want to add or subtract days or like any other part of the date, then you can use date add. So this will take 3 parameter, the part like which you want to add, the value, what you want to add or subtract, and the date on which you want to perform this operation. Let's see this with an example. So I want to find the date after 5 days from this particular date. Okay, so I'm calling this date add function. I want to add days, so I'm saying day. I want to add 5 days, that's why the second parameter is 5, and on this date I want to add these, right? So the third parameter will be the original date. If I execute this, I'll get 20th of the January. That will be the date after 5 days. If I want to find date after 15 days, I'm getting 30th of January. So I can provide positive values to add the days. If I want to go backwards, then I can provide in negative. So if I want to see 115 days before this particular date, I'll execute this. So I'm getting this 22nd September 2024. Okay, so this is how you can add days on date. So I can change this to like say month also. If I want to like let's say go 2 months back from this date, I can execute this. I'll get like 11th. I'm getting this 15th November. I can add months also if I provide positive date. And yeah, so this is also working. And similarly, I can provide year also. So that will also work. Yeah, so I'm getting this 2025 as the year. So we have this date diff that will calculate the difference between two dates. So if I want to find the difference in days, then I can pass a day here. Then the start date, first parameter will be the starting of the date, second parameter will be the end date, and then we'll get the difference. Let's see this in action. So I'm trying to find the difference between these two dates. So this is 1st of Jan, this is 15th of Jan. And if I execute this now, I'm getting 14 because there are 14 days between these two dates. If I change this to month, I should get a 0 because these two dates are within a month. So I'm getting 0 here. But let's say I'll change this to uh, some sixth month. If I execute this now, I'll get there are 5 months difference between these two. Similarly, we have year also. If I change this year to 2021 and execute, I'll get 4 because these two dates are 4 years apart. In this video, let's discuss about cast and convert functions that are available in SQL Server. First, let's start with cast function. Cast is used to convert one data type to some other data type. This is based on ANSI standard, meaning if we are using this cast in a script, then that can work across other databases also because this is ANSI standard. Okay, so this is the syntax that we need to use when using cast function. We need to say cast and then we need to specify what we want to cast like this, and then we need to say as and to which data type we want to cast. Okay, let's open up database and let's see this in action. So what I'm saying here, I'm saying select and then I'm using cast function. This is my first value. I want to convert this to what I want to convert, that I have specified as the like integer. So I'm saying cast 123.456 as integer. So when I run this, the SQL server will convert this data to integer data type, right? So this is how casting will work in SQL Server. You can see other examples also, like if you want to cast some string to a date, then you can say the date part, and as date you can specify, then the casting will be performed. Similarly, we have convert will also do the same thing. It will also convert one data to other data, but this has some formatting support also. And this is not ANSI standard, so you cannot use convert in other databases. Okay, let's see how this will work. Convert can basically take three parameters. First one, like to which data type you want to convert, what data you want to convert, and optionally you can provide some formatting. Let's see this also with an example. So what I'm doing here, I'm saying convert, and the first parameter is integer. I want to convert this data 123.456 to integer data type. Let's execute this. I'm getting 123. So this is also performing the conversion from one data type to another data type. Let's see the third parameter that we can use with the convert function. That is basically for the formatting. So based on the formatting, it will format the data what we want as the output. Okay, let's see this here. So I'm saying convert and I'm converting it to varchar. What I want to convert, I want to convert the current date and time, and I'm saying 103. So 103 has some special meaning. So when I execute this, I will get this particular date in this particular format. I'm not getting the time component here, right? So the date has been formatted. Just like 103, there are other numbers that you can pass, and here is the complete list that you can use here. So just now we have used 103 that will give the date in this particular format. And similarly, I can change it. Let's say I want the date in this particular format. So I can change it to 107. So let's see this also in action. So I will change it to 107. And if I execute this now, so I will get date in this format, first month, then the date, and then the year, right? And there are other things also, like if you want the date in this particular format where you have the time also along with the milliseconds, then you can use 1 to 1. Now I am getting the date along with the time. So this is the purpose of using convert function. Convert will do the data conversion also, but you can also optionally provide the formatting that you want to use. Okay, so here are the key differences. Cast is basically ANSI standard, so this will work with other databases also. Convert is used only in SQL Server. We cannot use formatting when we are using cast function, but you can use formatting when you are using convert function. Syntax is simple for cast, and for convert it is flexible, so you can use multiple parameters and do the formatting and conversion at the same time, right? So cast basically used for to convert other data type which are not date time, and convert is mostly used to convert date from one format to another format. Okay, so here is one other example. So we can format the date by these numbers 101, 103. So 101 will give you the USA time format. Similarly, 103 will give you UK, 120 will give you the ISO format. Let's see this also in database.